Welcome everybody to the October showcase focused on aerospace and defense. We're going to kick it off today with an open topic that's going to be industry agnostic, focusing on basically any technology that's innovative. After that, aerospace, where the focus topics there are going to be propulsion, materials, UAVs, predictive maintenance, support systems, as well as AI. Lastly, we have defense. Defense, it's going to be any technology that can support the warfighter. So, Deep Tech Showcase vision. Deep Tech Showcase's goal is to bring everyone together. Cutting edge technology is sought out from both everyone, government, corporations, investors. All of these different organizations are interested in having deep tech make it to their respective organizations. What we're doing at Deep Tech Showcase is we're helping these technologies get to market. The problem is that there's quite a few different barriers holding back tech startups. Complex tech, it can be really hard to explain. And not only when you do explain it, but it's just a whole slew. How to market it, when to market it, who to market it to, how much detail, how little detail. It's all questions that are relevant and can make or break technologies, unfortunately. Just because you have the most brilliant tech doesn't necessarily mean that you can time the market perfectly, unfortunately. So what we did is we created an ecosystem, and the ecosystem allows startups and stakeholders to connect and to meet each other and to get out of that rut that is the, to be dramatic, the innovation valley of death. So our stakeholders include anyone who is actively searching out and working with innovative technologies. This includes government representatives, major corporations, as well as investors. And the reason that we needed an ecosystem is because finding relevant technologies could be really hard. There are a large number of companies out there, and not all of them are necessarily deep tech. A lot of the changes we see, a lot of the time, sometimes it's incremental, sometimes it's huge. And finding the best or the most relevant companies to you can be a challenge. So in terms of the showcase, our events are, as I said earlier, monthly. And so this event that we're doing now is aerospace as well as defense. Our upcoming event is space and AI. And again, this is an event where cutting edge startups are able to pitch to a panel from all different walks, government, large corporations, investments, as well as, potentially there's a lot more people on this call who are, as well as partners, and many others who can really help bring this tech to market. Beyond our efforts in the events and ecosystem, we also work with startups when it comes to business strategy. This includes early market discovery, new verticals, building a viable business plan, deciding on an MVP, and designing materials for marketing and investors. We do all of these activities to help companies get to market. So we usually have a 9-month membership, and this includes 3 months of deep tech strategies. That includes consulting, figuring out what your market is, where you're best suited. Studio projects, meaning that we have an in-house designer looking at your materials, making sure they're good to go. Get to come to these events, obviously. In addition to that, we try to foster introductions between government, investors, as well as corporations. And lastly, and it's somewhat new, but we're also doing marketing as a service. So this is our team. You can see we have quite a few people. Tonight, I have to give a special shout out, or today, I have to give a special shout out to Yuval Herman, our director of events, who put a lot of time and effort into running this and putting everything together. Yeah, when the slides run smoothly, you know who it is doing it. And this is our events calendar. As I said, and I keep saying, today is aerospace and defense. Get suited up for space and AI next. And actually, in between our space and AI event, we're actually going to have a special event regarding AFWorks as well as MOUs on December 8th. I'm going to talk about that a bit in a bit. But if any of these events interest you, please contact Yuval Herman. He's more than happy to help you, find a spot there or join as a panelist there potentially.
Take him out.
All right. And so our next showcase is Space and AI. And 2 unique programs that we are ramping up now, actually. One is the MOU Club for AFWorks Phase 1 winners. The second one is StratFi and TACFi match funding. The MOU Club, it's a unique program we're running for the winners of a U.S. Air Force funding program called AFWorks. In order to receive larger amounts of funding, the companies need to gain interest from an Air Force customer and get a signed memorandum of understanding or MOU. Deep Tech Showcase, we put together with our sister company a program to assist companies to succeed at finding and getting MOUs or memorandums of understanding. Basically, what's included in this program are 3 different elements. The first one is one-on-one guidance, where the company that is searching out that MOU, we have a strategist that's assigned to them to help them with weekly meetings and making sure that they're going in the right direction, making sure that they're doing the right things and understanding, because a lot of the times we can only see things from our perspective, but seeing what makes the most sense in order to get the MOU. The second piece is we have a jam-packed calendar as well as a cohort. Where we are extremely active and having a real value add there. Again, I'm going to keep on pushing it. December 8th, we are having our AFWorks Winners Showcase. Feel free to sign up for that, or if you're interested, please reach out to us. But it should be a really, really great event. Lastly is writing the proposal, which Eagle Point Funding helps with. They do amazing grant writing. And then after you win the Phase 2, what Deep Tech Showcase is doing is helping with TACFi and StratFi, which is an option for public-private match funding for companies en route to working with the U.S. Air Force. If you're interested in looking into that, again, feel free to speak with us. And without further ado, let's kick off the Aerospace and Defense Showcase. Joining us today for the open topic session, we have Jan Liu from Hyperthrone Ventures, Bob Christopher from Diamond Edge Ventures, Marshall Witkowski from the Defense Innovation Unit, Stephen Potter from the U.S. Army Reserve, Joseph Anger from the U.S. Air Force, Han Ko from USACO Group, Sam Tallman from Invest Puerto Rico, Safraz Nawaz from Johnson & Johnson Supply Chain, Dana Jensen from the U.S. Air Force, and Destry Grogan from the Army Futures Command. And presenting today on this session will be Echo 3D, Skylight Wireless, IREX AI, Owl Autonomous Imaging, Real Random, as well as Argenteel. Without further ado, I turn the floor over to IREX AI.
Asher, we have a couple minutes if we want to just do a quick round table, make sure everyone's here, and just have the panelists say where they're calling in from today and who they're representing. Turn on their camera, say hello to the people. I think that could be a good use of the next few minutes.
Sure, absolutely.
Awesome.
Sam, you want to kick us off with a quick little introduction?
Sure. Thank you, Asher, and thank you, Yuval, for helping make today happen. My name is Sam Tallman. I'm a business development manager with Invest Puerto Rico, and I am calling in from beautiful, sunny San Juan. Very happy to be here.
Perfect. Han, you want to take next shot?
Sure, Han Ko. We're USACO Group. I'm the president CEO of USACO Group, and we are basically international venture capitalists. So we identify, invest in companies, and also do training. What's unique about our company is that we have we have an office in Seoul, South Korea. So I am actually about to fly out tomorrow, and I just want to add that I've been on this Deep Tech Showcase several times, and it's a great program. Thanks so much for having me here.
Perfect. Marshall, would you like to go up next?
Sure. So I'm calling from Morro Bay, California. I'm representing Defense Innovation Unit, part of the Department of Defense. And we're bridging the gap between commercial companies and military units, trying to identify and accelerate the adoption of dual-use technologies. Thanks.
Perfect. Jan, would you like to go?
Me? Yeah. Hi, I'm Yuan. I'm from Hyperthrone Ventures. We are the venture arm of Hyperthrone, which is the global leader in plasma and water jet cutting. And we are primarily looking at Industry 4.0 opportunities in areas such as robotics automation, AI, IoT, and advanced materials and 3D printing. So yeah, we are investing in primarily early stage opportunities. Yeah, excited to be here.
Perfect, perfect. Bob, Christopher, you're up next.
Hi, everyone. Good morning, good evening. Bob Christopher, I'm with Mitsubishi Chemical Holdings Company. We're a small company out of Japan. We make a lot of chemicals. So I'm on the innovation side and also on the investment side. So we do invest $1 million to $3 million in companies. This is our third year as a venture firm, and looking forward to the deal flow. Nice to meet everybody here.
Absolutely. Stephen Potter, would you like to introduce yourself real quick?
Yeah, good afternoon, everyone. Steve Potter. I'm calling from Detroit, Michigan, and I'm with the 75th Innovation Command, and we're a reserve component element that supports Army Futures Command. And my specific portfolio is autonomous systems, both ground and air, and robotics technologies.
Perfect, perfect. Dana, you're up next.
Yeah, sure. I'm Dana Jensen. I'm with the U.S. Air Force's Office of Commercial and Economic Analysis, where I'm a senior industrial policy analyst covering primarily aviation with an emphasis on advanced air mobility and all the enabling technologies that go with it, batteries, propulsion systems, materials, advanced composites, that sort of thing. And we play a very active role advising AFWorks and kind of playing matchmaker, even in the interagency with firms that we think are going to be important to the future of the defense industrial base.
Absolutely. Daron, would you like to introduce yourself?
Sure. My name is Daron York, also from Michigan. Go Blue. We are an early stage Cityside Ventures, early stage investment VC firm in Birmingham, Michigan. We're focusing on the EV market and specifically how it's applied to the DoD or aerospace and so forth. We invested in a few companies that innovative in the space. So glad to be here.
Perfect. Perfect. Happy to have you. Joseph, would you like to go?
Yes. So I'm Joe Anger. I'm the 56th Fighter Wing Innovation Superintendent here at Luke Air Force Base, Arizona. We oversee the Spark Cell and all innovation on base. And we're just looking for small companies that are interested in going for those SBIRs or bringing those technologies to the base to help increase our aircraft production and training for F-16 and F-35 pilots.
Perfect. Perfect. Thank you for being here. And last but not least, Destry, would you like to quickly introduce yourself?
Yeah, my name is Dr. Destry Grogan. I'm the Chief of Technology Development for the Synthetic Training Environment Cross-Functional Team for Army Futures Command in Orlando, Florida. So right now I own a technology integration facility, and we're coming online with a synthetic environment that starts to touch everything eventually within the portfolio of the Army as we bring in simulators and training capabilities from our live environment and our next gen constructive environments in order to do training for the future.
Nice, nice. Thank you. So you let me know, anyone who I missed, raise your hand, because I know there may be a few people on this list that I might have left out, but if not, more than happy to get the show on the road, Yuval, with IREX AI. I believe that Daniel will be presenting.
Yeah. Perfect. Hi guys, so my name is Daniel Ebrol. I'm the Global Business Development Director at IREX. I'm joined today by my CEO, Calvin Yadov. Our organization is IREX. We're a video-based service for evidence-based security, currently with the #1 ethical AI for public safety and smart government. I'm going to run through this in 5 minutes, so just hold on. Next slide, please. So we've built the complete ecosystem at IREX. First of all, we connect to IoT devices. We are agnostic to device, meaning that we can connect to any IoT device, but in particular, surveillance cameras. So any new or existing surveillance cameras, it doesn't matter which brand, make, or model, IREX, we can connect to those. Once we've connected to those, we just take a stream directly and run comprehensive artificial intelligence modules. We've run over 20 AI modules, which I'll talk about on the next slide. What we do with, no, go back one slide, please. So once we've run those AI modules, our ability to take in thousands of streams of cameras and then be able to run AI modules tailored to clients such as missing people, wanted vehicles, specific events such as crowding, vehicle accidents and so forth, and trigger those alerts to specific users and departments is kind of what separates us. On the flip side of that big data, we've got something called search surveillance, where you can upload a photo of an individual, type in a number plate or license plate number, or search for a specific event, and it will come up in chronological order. This is all displayed in a collaborative messaging platform system, which was built by the co-creators of Viber, which are on our leadership team. Next slide, please. So this kind of gives you a nice overview of what we've built. First of all, the sensors, we are agnostic to device. We connect to any IoT device, but obviously in particular surveillance cameras is what we focus on. We've taken all that streams and all that big data in our secure private cloud, which can be deployed on a data center of the client's choice or on-prem as well. We've got that hybrid offering. Now then, once we've taken all, go back, yes, sir. Once we've taken all that big data, we compare it with the government databases, such as it could be wanted individuals, it could be missing children, it could be specific vehicles of interest or alerts. So just for example, if a specific vehicle has appeared on surveillance and you need to receive an alert for that, we take in that information, that vehicle has popped up, it's going to trigger an instant alert by our collaborative messaging platform system to a specific department or a specific user. So that can be for events or individuals or vehicles. Next slide, please. So our AI modules, which we run once we connect to the cameras, we split them into 3 categories: threat detection, people analytics, and vehicle analytics. A testament to our artificial intelligence, which is all built in-house. We are currently ranked #1 by the National Institute of Standards and Technology for facial recognition. We beat Microsoft, we beat TrueFace, and this is all from surveillance camera. In addition, we've run, like I said, over 20 AI modules, from weapon detection to the license plate number to traffic jam notifications, fire, smoke, unattended items, and so forth. Each one of these AI modules is kind of the tip of the iceberg in terms of why the client might use them. There is thousands of use cases. Next slide, please. This is what the collaborative security messaging platform looks like. Any device, any browser. The ability to receive this information in real time and share it is revolutionary. Access any device, any browser. We've got a progressive web app, and it creates those virtual war rooms. Next slide, please. This is what the situation awareness looks like in real time. Now we're given the ability to receive alerts for wanted individuals, vandalism, fire, smoke, emergency exits blocking, overcrowding of individuals, weapon detection, and obviously recognition of persons of interest and vehicles of interest. Next slide, please. Our current strategy right now, we're focusing on B2G. We do a lot of direct sales to SLED and end users, governments, metros around the world. We've got partnerships with consultants such as Deloitte, system integrators, cloud providers, security providers, and also, like I said, we're ranked #1 for facial recognition. We've got a moral obligation to try and fight human and sex trafficking and find missing children. So we partner with all the missing children organizations across the United States to build our databases up, which is a revolutionary concept. Next slide, please. All the markets which we filter into right now is trillions of dollars. The video analytics market in particular is 21 billion, expected to exceed over 100 billion by the mid-decade. We're in VSaaS, we're in smart cities, we've built our own cloud, and so this is all in-house as well. Next slide, please. The current competitive landscape of what we are in the video analytics and smart cities domain. Nobody runs more artificial intelligence modules than IREX at this moment in time, and nobody's got the scalability. All these VMS systems and other competitors, they require only a certain amount of cameras. They don't have that scalability. We are connecting cameras, cities which are disjointed around the world, which might have different VMS systems. We're taking a stream from all these surveillance cameras, and then we are doing this at scalability compared to nobody else worldwide. Next slide, please. Our 300 million active sales pipeline right now is growing by the day. Our technology, which I've briefed you in, is all in-house, fully AI developed. #1 NIST ranking, various different topics, over 20 AI modules. This is not a sandbox. We're not just showing this, talking about it. We're in 50,000 cameras at this moment in time. It's tried, tested, and proved, and we're growing every single day. Partnerships, we are in, we've got around about 100 different partnerships right now in 30 different countries. And again, we're growing. Next slide, please.
30-second warning.
Yep. So this is IREX. This is what we've built. It's a revolutionary concept. We've got a fantastic team. We've got a 30 plus AI data scientists and engineers. We're a US-based company based outside of Alexandria, Virginia, and I'll happily share some of the some information in the chat. And you'll be joined right now with the Q&A with my CEO, Calvin Yadav.
And we'll send this slide out to you guys. There's a lot of backup slides in there too. And Daniel, you have my permission to breathe now. You can breathe.
All right, everyone. Thank you for the pitch, Daniel. That was wonderful. Just to remind everyone the rules, what we'll do is we'll have panelists raise their hand to speak, and then you could go in terms of the order of hand raised. Please keep your video on when asking a question. No one likes speaking to a gray box. Yeah, and moving from there, looking forward to hearing some good questions. Hanko, you were first. Go right ahead.
Thank you. Great technology. I'm really impressed. Do you have any restriction in terms of sharing or exporting your product or services to overseas? Any sense? In other words, some federal funding part.
Yeah. So we are right now talking in 30 plus countries. So we are a US based company, and there are certain obviously obligations we work with, but right now, so far, because we're a software company, we haven't came across any type of restrictions, and I'm using air quotes here, that what we can work and what we cannot do so far.
And we follow all GDPR rules as well of every.
Absolutely.
Right. Absolutely. Right. Thank you.
And we are not, I know Daniel was running through that, and there was a competitive landscape chart there. We are not a VMS system, and that's one of the things that we get sort of scooped up into, because the level of scalability that we have, nothing like this before IREX was existing. So we are kind of creating our own blue ocean here. And that's the kind of feedback we're getting from federal and state and local market too.
And of course, you filed all the intellectual properties, all that, right, to secure your IPs.
Yes, of course. Yes, we did.
Perfect. Perfect. Steven, you want to go now?
Yeah, I was wondering what current implementations you have active with the US government, and what contract vehicles you have in place to provide your solution to the government.
So it'll be a little long answer. Being a US company, but for our initial traction, we started getting from UK and European countries. I kind of believe that UK and Europe were a little bit more acceptable towards AI implementation into their sort of government sector. And this year, actually, we turn our head back to our own backyard, US. Right now, we are in a current conversation of pilots with about 5,000 911 dispatch centers. We're talking to US Coast Guards. We are talking to DARPA, and we are talking to US Army. And basically, all of these sort of deployments right now are at the early stage. So nothing has been put on a contract vehicle to be a specific answer, but they're all on early stage pilots right now. And there are a lot of, I haven't discussed obviously because of the time, but we're talking about over 300 million plus pipeline in the United States.
Thank you.
Perfect. Any other questions? Going once, going twice. So Yuval, how about we queue up Owl AI? Thank you, IREX AI. We're going to move on to Owl AI. Presenting will be Chuck Gershman.
All right. Can you put me in presentation mode, please? Thank you. Anyway, yes, my name is Chuck Gershman. I am CEO and co-founder of Owl Autonomous Imaging. Our team here at Owl has designed some of the world's most advanced thermal cameras for military and space application, and we're now addressing dual use applications for automated perception with our novel patented no-light thermal 3D computer vision system. So I'm going to show you a quick video here to highlight what we do. This is specific to the automotive market, but this is dual use technology. So go ahead, run the video.
Chuck, I'm just going to optimize it for a sec so it runs smoother. So just bear with me 1 second and we'll have it up.
At Owl Autonomous Imaging, we're all about safety. We use thermal imaging and custom thermal ranging software that allow us to detect pedestrians and range to them and locate them for autonomous automobiles so that we can have automatic emergency braking for pedestrians and to save lives.
Adding a thermal camera to an automobile for safety purposes extends the range of operation over using just visual cameras.
There are lots of low light cameras, but thermal imaging is a no light camera. So it can see pedestrians, it can see cars, it can see buildings at night with absolutely no light.
We combined an advanced thermal imaging camera with custom optics and artificial intelligence machine learning software to produce a 3D thermal image for use in automobiles to make driving safer.
We're an input to the system to tell it where there's a threat. The car will decide, hey, there's a pedestrian or animals, and either steer away from it or brake. Radar and LiDAR have difficulty with pedestrians between parked cars because they see the car first and they don't see the pedestrian. And because we're thermal, pedestrians really pop out of the image. There's no difficulty finding pedestrians or deer behind bushes. Anything that's warm-bodied just really pops out of the images. Our main target market is automotive, ADAS, and AV, but it also could be applied to other existing markets such as first responders, firefighters, and search and rescue. Obviously, it's always a good thing if you can save a life.
Today, in the United States alone, 6,000 pedestrians will be killed by cars. 76% of those pedestrians will be struck in poor lighting conditions, so nighttime or dusk or dawn. And the numbers are not decreasing. We solve that problem. We save lives, save lots of lives.
Okay, next slide, please. All right, so that gave you a good idea of what we do. And again, this is a dual use capability. In addition to no light, these are other conditions where thermal cameras are not negatively affected and visual cameras are. So all of these conditions a thermal camera can see quite well. So the market for what we're doing, our target markets are automotive, defense, traditional 2D thermal markets, as well as industrial heavy equipment and mining. This all adds up to an opportunity of about a $10 billion servable market, SAM, and a 37% CAGR. Next slide, please. Next slide, please. Sorry. All right, so our solution is disruptive. We're the only monocular thermal imager that operates in 3D. We have developed the world's first megapixel thermal sensor at commercial price points, and in a few years, we'll introduce a thermal sensor at the price of visual. Next slide. Early revenue comes from mature non-automotive markets, as we just discussed, where we already have design wins. We realize, next slide, please. We realize our billion-dollar potential via automotive penetration, where a design win with a single tier 1 systems manufacturer begets numerous OEM wins. And today we have pilots with Hitachi Auto and Honda, and have pending deals with all the companies denoted by the yellow check mark shown on the slide. Next slide, please. Within defense, we've secured over $3 million in contracts with another $800,000 in the pipeline for off-road application of our technology, specifically with the US Army and the National Science Foundation. This image here shows you the off-road capability. I should highlight that our solution is completely passive, so we enable stealth operation. And I also added a testimonial from one of the soldiers who evaluated our capabilities. You can see that in the blue here. Next slide, please. Versus the competition, we support both object identification and location in infrared. Our competitors only support identification, not location. And then on the y-axis, aspects of high quality include resolution, frame rate, sensitivity, dynamic range, and field of view. And again, simply stated, no other infrared competitor is addressing 3D depth perception. Next slide, please. Okay, so finally, why are we here today? Well, one, we're looking for additional ground vehicle partnerships within the federal market, specifically not simply with government directly, but with system integrators. Two, we continue to look to grow our OEM and Tier 1 automotive relationships. And finally, we're nearing closure of our Series A equity round, and we have an additional allocation of about $3 million that's still available to top off our round. So any of the investment community out there, we'd love to talk to you. And with that, I'd be happy to take slides. Next questions. Next slide. There we go.
All right. Thank you so much, Chuck. Bob, you raised your hand first. Go ahead.
Okay. Chuck, nice to meet you. I'm surprised we haven't had a chance to meet before. Actually, I worked at Panasonic in charge of advanced engineering. We did a lot of modules around cameras. Anyway, I'm curious about how you can train the data. So you had thermal imaging. I saw, obviously you're using, it sounds like IMU data to get the 3D distance. I'm wondering then, how can you take that data and fuse it, if possible, with the RGB data from a camera to then learn and understand if that is a specific person and if they're old or if they're young, because then a car can behave differently, right? So if the car knows a person's fast, they're a runner, they're a jogger, they can then say, okay, I'm gonna maybe slow down, but not stop. If somebody's walking across, this is something that I've a discussion that I've had with a couple of the Tier 1s, and they're trying to solve some problems. So I just curious about the training of the data and anything you could, any information you can provide.
All right, that was quite a bit there in that question. First premise, yes, we do train. We train both temporally and spatially. So for temporal training, we use a combination of IMUs and CNNs working together, because the IMU data sets unto themselves are not quality enough, at least low-cost IMUs. I mean, if we used a full-on gyroscope, that would work fine, but it's not really cost-effective. So we use a combination. We also operate spatially. So single frame produces depth through the generic term for the algorithm is monodepth. So that's a different training sequence than the temporal. So we use both, we combine them. As far as fusing a thermal with RGB, that is actually on our roadmap, and we'll probably be demonstrating that sometime in the next couple of quarters. It's actually not that difficult a process to fuse the thermal and the RGB together. One question is whether you start with RGB and fuse thermal, or you start with thermal and fuse RGB. More than likely, the thermal data is actually higher quality in some ways than the RGB, or less ambiguity. So we'll probably put the RGB into the thermal as opposed to the thermal into the RGB. But we already do some of that today for training purposes. So we use RGB data for training. So we do. So we actually use RGB data sets and train on them, and then map them over to thermal as well. So I don't know if I answered all of your questions.
Well, you did.
In terms of the recognition,
yeah,
we don't currently have a plan to classify based on age. We are classifying based on height and kind of height and weight, but we could certainly classify on some other metrics if necessary.
What is your timetable to get to price parity with a regular camera system, if that's even possible?
Well, I don't know if we'll get ever to complete, well, to get to complete price parity is a little bit of a stretch. So there's basically two main components from a cost point of view. One is the sensor, which, as I said, in 18 to 24 months, we think we can get the sensor price down, and we have some patents on this, very, very close to an RGB sensor. We can't change the lens structure that dramatically, and we don't actually build we design lenses, but we don't actually manufacture them. So the lenses will going to a pure plastic lens or a polymer lens is not in the near term. So the lens is always going to be a little more expensive than the RGB lens, at least for the foreseeable future, until polymers come along.
Thank you for that. That's an area that we're working on, by the way, at Mitsubishi Chemical. Lenses for sensors and to bring down price parity. So we can talk about that later if you'd like.
I'd love to. That's a real important, major problem from a pricing point of view to fix.
Perfect. Dana, go ahead.
Yeah, my question was about power consumption. I mean, historically, LiDAR has been power hungry and it's caused headaches for autonomous systems in ground vehicles. And I wonder, could you speak to the kind of power consumption parameters of this thing?
Sure. So first off, we are a receiver, not a transmitter. Hence my comment about it being purely passive. So first off, just basic mathematics, we only have half the circuitry of a LiDAR system, just at the 30,000 foot level. So right there. In addition, one of the things that we've done really differently than anybody else that makes up a preponderance of our patents is traditionally thermal sensors are built using analog CMOS components. So it's an analog ASIC, predominantly analog. Analog generally uses older technologies and very high speed analog to digital converters. We flipped the industry on its head. We've digitized our thermal imager. It's almost completely digital. So we digitize at receipt of energy, which gives us a digital circuit, which allows us to, instead of building chips at 180 nanometer power hungry process nodes, we're at 22 nanometer, super power sensitive. We have we're about 20 to 30 times less power per sensor than an analog equivalent. So our sensor system is significantly less power. And again, we're only a receiver. So compared to LiDAR, it's apples and oranges from a power perspective.
Are you considering working with any aviation, because you've got that third dimension? Autonomy may be easier to achieve when you've got that third dimension and you're working in an aviation context. Are you talking to anybody either in advanced air mobility or some of the traditional OEMs?
All right, so there's what the technology can do, and then there's how big the company is and exactly how much we can focus on. So since we do artificial intelligence, we're somewhat application specific. So we have this thermal technology that's applicable across a wide scope of application. But when we add the AI capability, it's specific to kind of subsets or individual niches. So yes, working in an avionic environment, unequivocally doable. It just doesn't happen to be. We just don't have the current staffing to focus on that today. Unless, of course, someone funded us in such a way that you asked us to kind of change direction, right? But it's certainly applicable.
Okay, sorry guys, that's all the time here. Thank you everyone who has questions. Anyone who had a question but didn't get to ask it, please message Chuck privately or even drop it in the chat or the Q&A. I'm sure Chuck will be happy to answer any questions. Next up, we have Steve Kelly with Argenteel.
Hi, the slides are going to have several builds, so you can guess. Hi, my name's Steve Kelly. I'm one of the founders of Argenteel. That's the company, and what we're about is automating DevOps automation. That's supposed to be a little confusing. Next. Next. First of all, what is DevOps? It's the process of getting application changes implemented in production. An example would be when the banks had to roll out the pandemic stuff in a hurry across the country. They had the app, but they needed to get it to apply everywhere. Two builds, please. And so this is common to almost every industry segment. Next slide. This is what how Gartner categorizes the space. In DevOps, you have the dev stuff on the left, which is building applications and is fairly well organized today due to agile processing. However, on the right, you have the ops side, and it's pretty disorganized and traditional. Gartner says there's 5 to 8 tools, and they don't work together to do that job. Bill? We're working with the Air Force, and they say the following: integrated in fielding software on the ops side of DevOps is very complex. We estimate that 2/3 of our software spending is in this area, so it's bigger than dev. And rapid deploy, use, and delete software is critical to many of their missions. So you need to be able to build it quickly, use it, and get rid of it. And yeah, these are in the industry, $200 an hour resources. Next. So what do? We provide a framework to glue all the other existing DevOps tools together, i.e. automating automation. So that's Ansible, Terraform, Python, Puppet, lots of others. And we do variable substitution at the end so that you can reorder a script to a target at the end of the process. We're not another scripting language. You start by uploading the scripts you already have and we make them reusable. So you don't need to learn new languages or start over. It works on any layer of the stack from bare metal all the way through infrastructure, through application and application configuration. And it works on any cloud platform, both public and private. Our long-term vision and our roadmap will actually begin to fully automate deployment scripting. Next. So a couple of early examples, an 8-hour task for HP, we did in 40 minutes. For a Microsoft partner, we did a 38-hour task in 3 hours. And for Dimension Data, we took a 200-hour task that they had done several times and probably spent more than 200 hours and did it in an 8-hour unattended overnight run. That's the kind of power you can get when you use this technology. Next. So how do we do it? We have a patented compiler that you feed with the libraries. The libraries can come from anywhere and generally come from the stuff you already have. Click. So once those are together, you provide a high-level workflow and the data for the specific target you're working with, and you will get an automated orchestrated deployment execution script out of the compiler. You don't have to write it. So custom or classified libraries can inform a patented compiler, and the libraries start with the scripts you already have so that you are, automating DevOps orchestration, not just storing, retrieving, and rewriting scripts. Next. Here's a quick look at a block diagram of the tool. I will not take you through it, but it consists of basically 3 parts. The script capture tool for making scripts that you get reusable, a workflow tool for assembling stuff for a new target, and a compiler which brings all the data and pieces together at the end. Next. Here's a picture of the tool. It's pretty techy, but it's easy to use if you're in the scripting business. Next. So what does Gartner say about this approach? They say it is something new. It's well positioned to work with all of the incumbents, and starting with the scripts you already have is going to resonate because everybody else is one way or another talking about starting over. It also provides a good means of organizing large DevOps teams. Next. Our current traction is with the Air Force. We've automated Active Directory deployment as an example. We're working with a couple of their contractors. We are an elite partner with Worldwide Technologies, and a company called Polyverse has chosen us as their deployment partner. We're pre-product. We want to introduce the product actually this quarter, but we'll do about $2.5 million in revenue this year, and we actually are profitable and cash flow positive. Next. We're going to introduce the product in Q4. We're seeking more funding from lots of government sources, and we would mainly like to recruit a lead investor to do a Series A round in 2022. That's it. With that, I'll take your questions.
Thank you for that, Steve. Whoever wants to hit things off, feel free to give it a start.
That's the first question. I'm sorry, I lost my voice. That's why Asher and you all are taking over for tools. Steve, can you just explain to us a little bit more about the DevOps world and then explain how you're unique in that space? Because I think it's a world that gets lost on a lot of us.
Yeah, so first of all, we're not about making applications. The application's been built. That's the dev side. The ops side is where do you put it and how do you put it on things all over the world? That is the coin of the realm. There is scripting. There are millions of hours spent every year scripting things. It's both deploying initially and maintaining over time and upgrading and patching and doing security pieces. It's a continuous activity. What we're trying to do is reduce that millions of hours by as much as 80% by automating the way things are done.
Thank you. Thank you.
Any other questions?
Han, any other questions?
It couldn't have been that clear.
Actually, I want to help Steve. He and I talked about this briefly. So I know that AWS and like WWT is one of your top customers, right? Can you tell us a little bit more about that to them? I think it means a lot to them. Thanks.
Well, Worldwide Technologies is one of our customers, and they, I think, do 12 billion a year in this kind of work. And we're both supplying with some talent and then getting them in position to adopt our technology because it can completely change the way they operate.
Thank you.
Perfect. Perfect. Thank you, Steve. Next up, we have Echo 3D. We're going to have Alon and Corin Greenspoon presenting.
Hey, everyone. Thank you so much. I'm super excited to be here. We're Echo 3D, a cloud platform for you to easily build 3D experiences, AR/VR applications, and games even. We are building the AWS for 3D. Next slide, please. We are a team of experts in 3D and cloud, having graduated from Columbia University. And we just raised a $4 million round with the support of Space Capitals, Convoy Ventures, Reimagine Ventures, Techstars, and angels from developer-focused companies like Datadog and GitHub. And we also received grants from Y Combinator and Verizon back in the day. We are basically the right team to make 3D content scale everywhere in the world. Next slide, please. Today, 3D content is everywhere. We see it in games like Fortnite and Roblox. We see it in AR filters on Snapchat, in so many online stores. Echo basically provides tools and network infrastructure for companies and developers to build games, AR/VR experiences, and 3D applications just like that. Next slide, please. But the problem is that building applications like that is really, really hard. Building 3D applications is frustrating. It takes a lot of time. Next slide, please. So similarly to how you can store images and videos on a remote cloud. Next slide. With Echo, you can store 3D models, animations, interactive content, and basically stream that to any device anywhere on the planet. Next slide, please. You're going to see a quick demo that basically shows how you can drag and drop content to Echo, and it will automatically be ready to stream across platforms to any game engine, mobile devices, web browser, or headset. Try to see if you can play that video in the slide. If it doesn't work, we can. Yeah, perfect. Hopefully that works. If not, that's fine too. All good, all good. So we can move to the next slide. It basically allows you to drag and drop assets and allow them to see them in headset everywhere. If you look at the applications today, there are kind of 3D apps and games. They're extremely large and super hard to update with new content. Next slide, please. With Echo, your app size is reduced by 90%. You save major time and money in building and updating your application, and basically allow you to stream a lot of 3D content anywhere in the world. Next slide, please. Today, we have over 12,000 developers on our platform who are already using Echo to build 3D applications like games, advertisements, e-commerce applications, and more. And we're getting between 100 and 200 new users registered every single week. Next slide, please. Paying customers and enterprises that use Echo at scale use us to create AR advertisements. One of the biggest mobile advertising agencies in Japan uses us. Companies in New York use us to build virtual workspaces to create a VR Zoom solution. We have NFT marketplaces who are powered by Echo and so much more. We were named a verified solution partner with Unity, which is one of the leading game engines in the world. And we also deployed 5G streaming projects with both Verizon and AT&T. So there's a big opportunity here to basically work with partners in order to allow 3D streaming anywhere. Next slide, please. Competitors who exist just don't cut it. We're the only 3D cloud solution that provides geolocation-based data streaming, real-time updates, and 3D compression. And as I mentioned again, we're the only kind of verified solution with Unity, one of the biggest game engines in the world. Next slide, please. Throughout our journey at Echo, we are obsessed with making 3D development easier. So we focus a lot of our go-to-market strategy around building a large developer community. We are there for major conferences, meetups, hackathons, and have collaborations with many university research labs. Also flying to Santa Clara for AWE. If anyone is there, say hello. Next slide, please. We're seeing millions of users rallying behind 3D technology and big players spending billions on new devices, headsets, applications, and game engines. And we're basically creating that cloud to connect them all. Next slide, please. Recent trends around user adoption and 3D hardware and content in 5G really introduced endless numbers of 3D AR and VR use cases. If it's data visualization or navigation or marketing or gaming, e-commerce, and more. Next slide, please. And our mission here is to basically help companies build and deploy 3D AR and VR applications. We are looking to partner with companies like yourself and government organizations, basically leverage Echo's dual use and multiple use technology to stream 3D data over satellite internet, headsets in the battlefield and in space, to basically empower people to get more and more 3D content and spatial aware content. Next slide, please. So if you want to learn more about our efforts to build the cloud for 3D AR and VR, you can reach out, or if you actually scan this QR code right now, we will stream 3D content to your phone with no installation needed, no nothing, just 3D data. You're going to see the Empire State Building on your phone right now. Just scan this, redirects to our website, you click scan AR, camera pops up, and data is streamed from our cloud to your phone in real time. So definitely check that out. Thank you so much. Thank you for the opportunity, and welcome any questions.
Sure, thank you, Alon. Thank you. I got it loaded up on my phone here, actually.
Love it.
Yeah, that was great. Yeah, so feel free. We're gonna open it up to the panel. Whoever wants to take it away can take it away.
Alon, can you talk, are there any defense applications where you're building?
Yeah, definitely. So a lot of the things that we're seeing right now is, and you've probably seen the US Army buying tons of HoloLens, Microsoft mixed reality headset. We connect to devices like that, basically allowing you to have heads-up displays for soldiers in the field, allowing you to synchronize those devices at the same time and in real time, similar to how I just shared a QR code, and maybe I'll share a link as well. We can basically synchronize all of these devices, build really simple applications that allow people to see data in real time. And that's just one kind of the quickest use case for the battlefield.
I know at least the old language around this topic was MDO, multi-domain operations, the ability to like share information from front back to war rooms, etc. And it's something to probably look into.
Yeah, 100%. I think what's really unique about our platform is that it does kind of allow the decoupling between the user and the content manager, which in our case could be, again, the war room and the soldier, because it literally allows you to drag and drop content and it's instantly available anywhere in the world. And as I mentioned, again, you literally scan a QR code or use the link I just shared, and you'll be able to stream 3D assets to your device anywhere.
Wow.
Awesome. We just got a message from the Q&A, Josh. Sorry to cut you off. Can Echo 3D do the same thing for high resolution image data from sensors?
100%. So I didn't mention it, but when I say 3D content, images and videos like legacy 2D content is also encapsulated under that. You can upload images to Echo, you can upload videos, and we optimize that stream. You just have the added benefit that you can also stream kind of 3D content. I can share a medical thing that we did with Columbia back in the day, that basically we connected to a kind of this X-ray sensor, X-ray kind of device, and based on the data from that, we were able to stream 3D data and change it remotely. So definitely any image sensor could work with that as well.
Awesome. And I think there was one other question in the chat. How is the data protected?
So we encrypt everything, everything through SSL, but also we anonymize it. So when you upload content to Echo, even we don't know what that kind of 3D model is, because all the data is being stripped down. Under the hood, we also have this kind of multi-cloud strategy, which means that the data itself sits on one server, the 3D models themselves sit on another, the images on another. So even if you have some kind of attacker who's really dedicated to getting the data, if they get just one piece of the puzzle, it's completely worthless without the others. So we're really, really conscious about kind of data. And it's something that like privacy by design is something that we kind of take to heart. It's in the DNA of the company.
Great. And then there's a few more. One other question in the chat, and there's a few other ones you should look.
Yeah, I see in the chat here. So do you plan to support interactive 3D content? So 100%, we already have that support. If you uploaded an animated 3D model to Echo, it will work automatically. It will be interactive. You can also use Echo to add buttons, add interactions through the console with no code, which means that, let's say I shared the 3D model of the Empire State with you, we can add a button, learn more, sell now, stuff like that. So great question. It's something that really works well with training and kind of having training applications that basically go through different stages, something that you can build with Echo with literally just a few clicks. And we have another question from Dennis here. How much does it cost for developers to get started? You can literally go to our website right now and register for a free trial. One of the things that we love most is kind of minimizing time to hello world. So the time for you to build an application should be really, really small. The conversation that literally the talk I'm giving at a conference in California next week would be how to build a cloud connected app in 15 minutes or less. So you can literally use Echo to build a fully fledged application in 15 minutes. I would definitely recommend go to our website and try that out yourself. And the price structure basically builds on bandwidth, storage, and API calls. So the more cloud resources you use, the more you pay, very similar to AWS or something like that.
Perfect. All right, thank you so much. Anyone who would like to ask any more questions to Alon could message him. I'd like to remind everyone to please have your cameras on. No one likes talking to a small gray box. Moving forward, we have Skylark Wireless. Ryan Guerra, I hope I didn't mispronounce your name, is going to be presenting. Take it away.
Excellent. Quick mic check.
Perfect. You're good.
Thank you. So thank you. My name is Ryan Guerra. I'm co-founder and CEO of Skylark Wireless, and we go beyond current 5G standards to provide longer range service and more data and more users on the same network infrastructure. Next slide, please. Quick introduction, myself and my co-founder came out of Rice University PhD program. You're looking at the first massive MIMO hardware prototype built in the world that was real time at Rice University, and that's my co-founder's arm in the background back from 2012. We found a whole bunch of scalability issues, we solved them, we patented them, and spun that IP out into Skylark. Next slide, please. Real quick, we focus on a technology, core 5G technology called massive MIMO beamforming. Our platform is called Pharos. Pharos means lighthouse in Greek. At a high level view, if you look at a 4G, 5G NR radio, you put it on a tower, it broadcasts energy in a sector, and you get some range and performance as shown on the left on this picture here. For a massive MIMO system, you use an array of low power radios at the base station that actually cooperate to focus that energy at the intended user. You increase the signal strength, which increases the range, the reliability. And one of the neat things is because I'm not causing interference with that focus beam, I can actually do some smart math at the base station and form multiple beams to multiple users on the same channel and at the same time. And for the purpose of this talk today, I can not only steer my energy, but I can also steer my nulls as well to mitigate interference. And that works on both transmit and receive. Now, for every beam that I add to the system simultaneously, that's a multiplier in capacity. So 8 beams, 8x more capacity, 8x more users, or 8x more data to my existing users that I now have the ability to schedule to everybody of maybe thousands of users in that network. These beams are calculated in real time based upon the environment, and they actively track users as they move around and switch between, again, potentially thousands of users in the environment. Good morning. Next slide, please. We've implemented this technology on top of our own software-defined massive MIMO radio platform. Kind of unique to Skylark is we build these systems in a highly scalable, highly flexible, and agile way. Just about any frequency below 6 gigahertz. customized frequencies as well, because these are software-defined radio platforms. They are assembled and manufactured here in the US. So you have as domestic a supply chain as you can get with RAN technologies. And you can see some of the top level speeds that you can achieve and the scalability of the system. More radios on a tower equals more capacity, more users. So you can scale that as needed. This is a dual use technology. It has obviously commercial and military applications. We have patented our beamforming enhancements and interference mitigation, and it is uniquely scalable. This is not something that any other vendor is doing today. Next slide, please. On the commercial side, one of the reasons of throwing all this really neat technology at next generation radio access networks is that you can bring down the average cost for providing broadband significantly, an order of magnitude, maybe even 2. So if you look at 250 USDA greenfield projects for rural broadband through the Reconnect program, the average cost per household, CapEx, was about $7,800 per household. No business without subsidy can actually make that work to provide broadband, high-speed broadband. A similar project through the same program using Skylark's Pharos technology, the CapEx was $420 per household passed and about $1,400 per household served after you did a truck roll, installation, everything and everything. So you can see the huge cost differentiator there. Next slide, please. We are focused on a B2B OEM business model where we do network design so we can optimize this unique technology for your application. We provide the systems, the base station equipment, as well as user equipment for the receiver. And then actually the software stack to manage, control, and bill for the entire system. We really are a one-stop shop for a private network. Over the past several years, we've been selling to R&D customers, corporate research labs, universities. Microsoft Research is our biggest customer there. Couple of wins in the DoD as we moved into the commercial space. And we're about to certify our first commercial system for deployment by rural internet service providers. Should be certified Q1 next year. Next slide, please. The total available market for these kinds of systems, if you just focus on the fixed wireless access, so not terribly mobile, maybe somebody walking around with a wireless box hotspot, that's about $2 billion per year, and that's the market that we're entering next year. We are currently integrating technologies that will allow us to serve the consumer device. So think a mobile device, phone, off the shelf, standard based, and that will allow us to step into the private 5G market, which is about 70 billion worldwide. Next slide, please. Several wins over the past year or so that are quite important. Again, stressing assembled in the US. It's very unique for companies to actually build 5G and similar systems here in the US. We are recipient of a 3-year, $11.7 million 5G Next-G prototyping award from the Air Force for 3.1 gigahertz coexistence, 5G coexistence platforms. We are building out, selling equipment to Rural Digital Opportunity Fund broadband projects in multiple states. Another thing that's relevant for the discussion here, we were just awarded a direct phase 2 Army X-Tech SBR to basically take one of our systems and adapt it for land mobile use and bring more 5G capabilities to the CMOS and more ecosystems, radio ecosystems. Next slide, please. We are currently seeking a $5 million non-participating preferred round. This goes out to the investors in the audience, looking to help us certify our product, scale production, and build our sales and support teams going forward. Next slide, please. So to wrap up, we build patented long-range 5G systems. We go beyond current standards by quite a bit. We build these systems anywhere below 6 gigahertz and optimize technologies for below 6 gigahertz applications, all the way from DC to 6 gigahertz. And this is our contact information. Please feel free to reach out. And we'd love to share more details about our Gen 2 system that is currently prototyped and demoing, should be demoing to customers in December. Thank you.
Thank you. Thank you. All right, Bob, kick it off.
Okay, thanks. Great, great presentation. Question about thermal management. 5G produces a lot of heat. How are you dealing with thermal management in your system?
Yeah, absolutely. Great question. That we see as twofold. In Gen 1, we actually, that was not thermally optimized. That was one of our biggest issues when we deployed these in the field and had them running for years on end. We've actually had that Gen 1 system in customers' hands in proof of concepts, et cetera, for some time. Gen 2 focuses on hermetically sealed, fully passive cooling, industrial temperature grade, et cetera, et cetera. That's meant to go on a tower and sit there for 8 years without anybody touching it. That being said, we know there's a Gen 3. We know the pathway. That's going to be the next step. And actually, one of the things that we're interested in working with the military side is swap, size, weight, and power for next generation architectures for these systems.
Great. This quick follow-up question. How are you handling backhaul, long haul data? Are you doing repeaters? Are you connecting with photonics? How are you, how are you managing the data?
So we're generally agnostic to that. On the commercial side, for high quality of service, we obviously prefer a fiber backhaul right at the base of the tower. You know, you want to serve 7 gigabits of user data, you better have a fast pipe leading back to an interconnect. But we are agnostic. So, you know, if it's a microwave or if it's a satellite backhaul, you just connect at the switch and there you go.
Okay, thank you.
Han, you're up.
Thank you. A great solution, actually. This is another just technical question. How can you tell us a little bit about in terms of those typical hurdles that massive MIMO has? You know, those challenges like a signal to interface ratio, and then also reciprocity error, stuff like that. You know, how can you relate to that, please?
Yeah, 2 big issues. I'll focus on 2. There's a whole bunch. We'll have to have another conversation, a little bit longer than 5 minutes. But there are 2 big problems that we solve uniquely. The first is range. So if I know where you are, I can beamform to you, and then I have a high SNR channel to you, and I can do all of my handshaking and network control via that method. If I don't know where you are, I actually can't beamform efficiently. And so we actually solve that problem uniquely. And that's one of our patented solutions, is a long range control channel, which allows you to actually operate massive MIMO at the limits of its theoretical range. The second issue that you mentioned, interference. One of the issues when you have users that are moving around rapidly, so think a car or even an airplane, say, one of the challenges is if I focus a beam at somebody where I think they are and they move out of the way, then now I'm causing interference, not only to that one user, but that user's causing interference to everybody else because the system is designed to null users that you're not interested in. So that's a key problem with massive MIMO. One of our patents focuses on identifying in real time which users are more rapidly moving and then dedicating more channel estimation resources to them so that I don't clog up the capacity that I get with massive MIMO with the overhead to manage channel state information collection. Again, I can dive into the details, but that is a patented solution that we don't think anybody else can meet.
Very impressive. Well, thanks so much. You seem like you have a solution for all those major hurdles. Thank you.
Thank you. Yeah, we ran into all the issues really early on.
Perfect. Thank you so much, Ryan. Up next, we have Real Random, and Doug Hill will be presenting Real Random today. The floor is yours, Doug.
Thank you. I'm excited to be here today. I'm Doug Hill. I'm the founder of Real Random. We're based in Tampa, Florida, and our mission is to build a safer digital world. Next slide, please. The problem we're solving for is the threat of quantum computing, and that being a threat to national security. And when we think about quantum computing, we want to look at what we have today in von Neumann boxes and modern computing, where process is linear, one input and one output. When we think about quantum computing, we want to think about parallel processing and the computer's ability to process all possible combinations of a cryptographic key simultaneously. Next slide, please. And so when we consider Roger Grimes, who's a author of more than 15 books and well-publicized evangelist of computer security, we want to think about how quantum computing is going to affect us, not just in the positive ways in developing new vaccines, but Q-Day. When is Q-Day? When is the day that quantum computing becomes useful as a weapon for cybercrime, and espionage. This is a book I recommend anyone who's interested in quantum computing and computer security that they check it out. Next slide, please. So as a practical example, if we consider a cryptographic key as a maze, if I'm an attacker, I want to identify the seed state where I then can determine a pattern that leads me to successfully decrypting the key. And so if I think about linear processing, I can try only one combination at a time, just as a human takes a pencil and that paper to attempt the key. And we'll move to the next slide. We can see that in parallel processing, you're able to try all combinations at the same time. That's a big problem when we consider public and private key infrastructure that's used today to safeguard our data and protect our network systems. Next slide, please. So the solution is better entropy. Entropy is a measure of the lack of order. If you consider your first day of high school, that was a day that had very high entropy. It was a day when there was a lot of confusion, a lot of chaos. And so when we think about computer security, staying one step ahead of that bear is the idea. We know the bear's coming, and we know that there are options and things we need to prepare, especially with things like quantum computing on the horizon. And so the solution is better entropy from physical non-algorithmic sources to use as seed values for cryptographic algorithms. The plot on the left is from atmospheric noise, and you can see clearly that there's no detectable pattern, versus on the right, that this is classic pseudo random number generator, or you're using a mathematical formula to take some value that's been derived from the computer network itself. Next slide, please. So there's been some improvements in non-algorithmic entropy. On the left, we can see that Intel's classic mathematical entropy, where data is collected, random data points, and used to seed cryptographic algorithms, generate keys. The problem is that anything that's engineered can be reverse engineered. And so it's deterministic and can be predictable. And that is how those keys that are securing our network can be cracked. And so in the center, we have Cloudflare, a leading content delivery company that's using centralized biomechanical entropy, actually 100 lava lamps on the wall of their headquarters. And they stream video and hash that video to get the randomness out of the video and use it to seed their cryptographic systems so that they have a completely unpredictable source of random numbers, but it's not scalable for data centers. So what we've developed is that same approach of physical non-algorithmic entropy in a reliably unpredictable design for data centers. And so a rack-mount system where you can have the devices installed for on-premise generation of entropy in order to seed your cryptographic systems. Next slide, please. What makes us unique is that our process is visually verifiable. You can look at the device and understand that the device is acting in a way that's intended, engineered to act. And you can see that it's truly a random output, much like shaking a snow globe, except that we've configured it to slide into server racks to be an appliance for a consistently reliable source of unpredictable true random numbers. And it's not subject to supply chain attack. And that's a really important point. If I have a Geiger counter, which is commonly used, or other sources of entropy using atmospheric noise, we can't see radioactive decay as a human. And so in our device, you can look at the device and, again, understand that it's doing what it's supposed to do and have that confidence that you're not producing random values just from copper and plastic on a chip. Next slide, please. So this is the physical proof. This is our only statement. This is our ability to show our customer how the random number was generated. And the customer owns this. When you generate a key today from, let's say, a service, it's generated typically from an algorithm and you trust it. In our case, you can see it and believe it. And so this is an excerpt from our user interface that manages our hardware. And it's important because it's the root entropy. You actually own that source of the random number. The next slide, please. So we now have a TRL 6 commercial hardware prototype as of July of this year. We have utility patents filed for secure end-to-end communication for things like protecting UAVs and really any IoT connected device. We're working with SoftWorks, a Tampa, Florida-based innovation lab for the US military in order to develop type 1 in-field encryption for the warfighter, where they will be able to provision in real time unique one-time passcodes for their hardware. And they will have the assurance of knowing that the device is operating in the way that it's intended to operate.
30-second warning.
Thank you. So we are seeking opportunities for technical integration programs with defense, banking, and healthcare organizations in order to share our technology and advance the development of the technology to build a safer digital world. Thank you.
Thank you, Doug. Thank you, Doug. We will now be opening the floor up for Q&A. Whoever wants to ask, jump in. Otherwise, Josh, the floor is yours. All right, Han.
Yeah, I'm usually the first one here, right?
Hey,
can you tell us about your business side of it? Do you have any traction or any plan, or could you tell us a little bit more about that? You have great technology, actually. With the quantum computing is the way it goes. Yeah, it is definitely a concern. So thanks.
Thank you. We're just transitioning from being an R&D company for 6 years. It took 7 generations of hardware to get to where we are today, because we weren't able to take something that was pre-existing and improve upon it. There's never been a true random number generator that's hardware-based, that's analog, and uses an electromechanical process. And so really SoftWorks is our foray into supporting the warfighter. And we are looking to build on that with other similar opportunities, whether it's DefenseWorks or AppWorks, et cetera. So at this point, our traction is SoftWorks and that opportunity.
Thank you.
Thank you.
Bob, the floor is yours.
Sure. Thank you. So are you creating a visual language around these random numbers and then this language that becomes a library? I'm just trying to think, how do you extrapolate from there a greater data set that would say, here's similarities in random numbers and sequences and that we're seeing in different attacks? Is there a way to just gain intelligence of pattern recognition through your image, your visual language system?
We are not creating a visual language system. We are creating a resource in the form of an API for seeding things, whether it be for simulations in a SOC or Monte Carlo simulations for banking industry. So we are not creating a language. We're simply creating a source for true random numbers or pure entropy.
I'd like to see your presentation because it doesn't quite. I heard what you said, and I work with quantum computer startups. So I know enough about quantum computing. I know that's not what you're doing, but I also know how some of them operate. I just like to talk more about this in depth offline. So I have some questions about that.
Thank you.
Yep.
Perfect. Thank you so much, Doug. With that wraps up our open topic session. We will now be moving to our aerospace section. And so we're going to be kicking it off with aerospace. So first, we're going to keep on quite a few panelists. Han Ko is going to be staying on. Bob Christopher also is going to be staying on. Joining us will be Alan Yu. Also joining us will be Ryan Hatcher from Lockheed Martin. Joseph Frere is joining us from the U.S. Air Force. Darshan Dubarkan is joining us from AFWorks. Yoav Wazer is going to be joining from NextGear Fund. Robert Yancey will be joining from Hexel Corporation, and Marshall Witkowski will be staying on from the DIU. Stephen Potter is also staying on from the U.S. Army Reserve. Dana Jensen from the U.S. Air Force will also be staying on, and Joseph Anger from the U.S. Air Force will be staying on. Thank you to all the companies who presented in the open topic. Moving to the aerospace topic, we're going to be having Scope AR, Adranos Incorporated, Elementum 3D, Patero Dynamics, and Viz AI. So without further ado, let's give a couple seconds for the new panel to introduce themselves. If we have time, right, Yuval?
Yeah, we're good. And also, obviously, thank you so much to all the panelists who joined us till now. Also, those who will be leaving, also those who will be continuing. Happy to have everyone here, as well as the companies.
Sure, perfect. So, Han Ko, kick us off with telling us a few words about yourself one more time.
Sure, my name's Sure, thank you. Han Ko, Isacro Group is an international investment venture capital company. We have operational based in USA and then also Asia, especially South Korea. So hopefully we can work together in the future. Thank you.
Bob, please reintroduce yourself. Thank you.
Sure. Hi, sorry. Bob Christopher, Diamond Edge Ventures. We're a division of Mitsubishi Chemical Holdings Company. I'm on the innovation and investment side. Looking forward to the event.
Awesome. Alan, you from Space Capital.
Hi, everyone. We're Space Capital, early stage New York-based venture fund focused on space-enabled technologies. I've been investing in space since 2012. We have a venture capital fund and also a growth fund in an angel platform. Yeah, looking forward to the event.
Perfect. Thank you. Ryan Hatcher from Lockheed Martin.
Hi, Ryan Hatcher. I'm a corporate tech scout, reporting up to the CTO. I don't have any money, but I look for companies that are aligned, have technologies and products and services that are aligned to I would say, strategic needs across Lockheed. And then I look for ways to engage those companies with the key stakeholders in Lockheed. Thank you.
Perfect. Joseph Frere.
Hi, name's Joe Freyer. I work for the Air Force's Office of Commercial and Economic Analysis. I'm a colleague of Dana's from the previous panel. Our role is to pay attention to markets that are relevant to the Air Force and be able to provide market analysis to our stakeholders, who are all Air Force agencies and DoD agencies. Yeah, I want to apologize for not having my camera on right now. I got two computers. One has a camera that doesn't work and the other has a microphone that doesn't work. But I promise you, you're really not missing out on very much. So looking forward to the event. Thanks.
Perfect. Thank you. Next is Darshan Dash.
Hey everyone, I am Darshan Dubarkan. I am the Senior Operations Research Analyst with AFWorks, also with the United States Air Force. I work extensively on various programs, including App Ventures, the Cybersetter program, a prime initiative where we are focusing on electric vertical takeoff aircrafts and how to operationalize it by 2023. In addition, I also work extensively on industry engagements, including federal and academic side. So everything possible I'm involved in within AFWorks. Thank you.
Perfect. Thank you. Next up, Robert Yancey from Hexel Corporation.
Yeah, I'm happy to be here. So Bob Yancey with Hexel. I lead new business development for Hexel. Hexel is a major supplier of composite materials to the commercial and defense aviation industry. And I primarily look after emerging markets, so things like air mobility, UAVs and so forth. And so interested to hear the technology that will be pitched today.
Perfect. Thank you. Marshall Witkowski from the DIU.
Sure. So I'm Marshall Witkowski at the Defense Innovation Unit. I'm a commercial engagement executive for our autonomy and advanced energy and materials portfolios.
Perfect. Thank you. Stephen Potter from the U.S. Army Reserves.
Hey, good afternoon. Steve Potter with 75th Innovation Command, and we provide support to Army Futures Command in tech scouting, and I oversee the autonomy and robotics portfolio for the 75th.
Perfect. Thank you. Dana Jensen from the U.S. Air Force.
Yeah, hi, I'm Dana Jensen. I'm with the U.S. Air Force's Office of Commercial and Economic Analysis, and I think several of my colleagues are in the panel here as well. I focus on advanced air mobility like Dash, although my emphasis tends to be on the supply chain. So I look at some of the emerging enabling technologies that will allow this to happen, like advanced propulsion systems, advanced composites, and Bob also is a good friend and good contact along those lines. And obviously batteries and other things related to getting these things into the air.
Perfect. Perfect. Lastly, Joseph Anger.
Yes, so I'm the 56th Fighter Wing Innovation Superintendent here at Luke Air Force Base, Arizona. We're just looking to bring innovation and technology into the base for us to increase aircraft production and pilot training. We work closely with AppWorks and a lot of smaller companies that have been chosen for Phase 1, Phase 2 SBIRs. So I'm looking forward to everything. Thank you.
Thank you. And if you were a panelist on the last session, feel free to stay on, feel free to sit on. This session should be really, really interesting. We're going to kick it off now with Elementum 3D. Jacob Nectarlane, founder and president, will be presenting.
Okay, can everyone hear me?
Loud and clear.
Yep. All right, great. Thank you. Yeah, as you mentioned, I'm Dr. Jacob Nectarline, founder and president of Elementum 3D. We develop new materials for additive manufacturing or 3D printing. Next slide, please. So really what we do is we supply materials and we supply the entire chain of how to develop, use, and post-process those materials for the 3D printing market. We've developed new alloys like aerospace grade aluminums for a very heavily aerospace grade market. Next slide, please. So what makes this different? Well, typically you can't print these very high strength aluminums for the same reason you can't weld them. We've solved that problem with our reactive additive manufacturing process, and we've been able to then provide a menu to engineers. Next slide, please. It really opens up the possibilities to all sorts of different alloys, not just aluminums, but in this case, you know, there's no Goldilocks material for every application. There's no Goldilocks material. For example, maybe an engineer wants a high thermal conductivity or a higher throughput or a higher strength. We really provide that by being able to supply materials that are either equivalent to the wrought materials that are available or new materials that weren't possible to make without 3D.
Randomly generated.
Next slide, please. So I think it's really important to back up and talk about the business cases. So why 3D printing? Why additive manufacturing? There's three primary business cases and then one that's up and coming. The first, lightweighting, typically that's not a business case on its own. That can be helpful and attached to the other business cases, but it's not typically a good enough case on its own. But printing designs that you can't otherwise is really important. This is really taken over in a lot of industries like rocketry and others. But being able to make cooling channels that hug contours or manifolds that wrap and direct fluids in different directions, really complex antennas, that's really where additive manufacturing can shine. The next business case being combining parts. The ability to be able to take, say, for example, a helicopter engine that was 900 parts and make it down to 20 components. Being able to keep track of the supply chain is so much simpler. And then also being able to repair these parts. Imagine a repair technician. Maybe there are some really special people out there who can keep track of 900 parts, but it's far easier to imagine someone who knows these 20 components, knows which parts to repair, which parts to replace, when it's only 20 parts. And I think that's an important aspect to this, of being able to simplify that supply chain, simplify the parts, simplify the understanding of how these different really complex systems can work. And then the newest business case that's really up and coming is the logistical improvements. Reduction in warehousing to where you can really decrease the size and number of extra parts that you had to make in the original production. Improving the national security. Imagine a forward operating base where basically you can ship the material and it's just a lot of metal powder, and then you can email over a secure chain directly to the front line the really complex and difficult to control parts. Next slide, please. So what makes Elementum different? Well, we developed these new alloys and they're great and they do a lot of different things. They're very high strength, but the most important part that we've gotten feedback on is the consistency. Being able to have the same results and the same strengths, everything be exactly the same from print 1 to print 10,000 is incredibly important. And so having this wide process window and therefore really consistent product tends to be more important than peak strength or anything else. Although we have highest strength materials available as well, it's really about consistency. And so we like to demonstrate that by providing fatigue data and really testing a lot of these materials. Next slide, please. As part of that, we have flight heritage. We have parts flying today. We have parts in space. We have parts that have gone through all the way through to an A basis equivalency, an MMPDS. And have parts with obviously our customers like Ball Aerospace, Orbital Microsystems, Northrop Grumman, Lockheed Martin, and where we help them realize their designs and make their designs out of high strength materials. And we've spent quite a bit of money going after the data to be able to support that, to sell that to the end customer, which is typically DoD, DOE, those sorts. Next slide, please. I'm going to touch on this briefly. We now have 50 employees. We're moving into a 76,000 square foot facility and really have gained some traction. We have a team that's dedicated in developing new materials and alloys for additive manufacturing exclusively, with over 45 years of experience at the PhD level. Next slide. An important part of that, I mentioned a couple of our customers before. We have really close relationships with them. Northrop Grumman goes to trade shows and talks about our 7050 Ram 2. Ball Aerospace goes to trade shows and writes articles about our 6061 Ram 2 and how it's working and why they're using it. But we have really close relationships with our suppliers as well, and the suppliers of the printers. And we do quite a bit of different government contracting, both as the prime and as the sub to a lot of these companies. And there's plenty more that we can't talk about as well. Last slide, please. So what are we looking for? We're looking for expanding and adding more partnerships and relationships with customers to leverage our materials and our manufacturing capability with their manufacturing's background and their materials and design background as well. So we really pair well with a lot of the larger companies and can go after all sorts of different projects ourselves as well. And we're looking to go into projects on weapon systems, aircraft components, all sorts of things. So yeah, thank you for your time. Any questions? Happy to answer them.
Thank you. Thank you, Jacob. Opening the floor, Han, go ahead.
Yeah. Question actually. So I know you have some, you presented some fatigue data and things like that for your solution, but how do you get around, the 3D printer parts are usually generally not as dense as a part made by like CNC and other processes, right? So can you kind of, could you comment on that a little bit, and how your product is, how your solution is actually overcome those typical problems?
Yeah, so laser powder bed typically doesn't have that problem. So we can dive further into that, but there are multiple different types of printing, particularly laser powder bed. I mean, our 6061 is 99.98% dense, which is far more dense than a casting and as dense as any forged part as you're looking for. So certainly we're getting properties that match that or beat that of the wrought materials.
Right. Thank you. Appreciate it.
Perfect. Bob?
Yeah. So you're selling materials, and are you also acting as a service bureau to print parts?
So we do have 8 printers in-house, and that's a significant capital investment. But those printers are really dedicated to producing first components and then helping that kind of pilot factory stage that we can then transition to the OEM, say Lockheed Martin, Northrop Grumman, whoever they are, and really help them then support their own production with their own components so that we're selling the material. So we're not trying to compete with our customers, but we are trying to provide a service where we can help them get started.
Okay, thank you.
Perfect. Dana, the floor is yours.
Yeah, sure. So we've done a little bit of analysis of the supply chain for 3D printing, and we're quite frankly a little bit alarmed by the few number of suppliers of powders, whether they be advanced powders like you're talking about or just the more conventional stuff. I wonder if you could comment on who you see as your primary competition or who you may be seeking to disrupt in the market. I don't know if you can name names or if you just want to talk about it more generally.
Yeah, so certainly there are competitors, and I think that's really a healthy thing for the stage that we're at. And it's one of the reasons that we're going up that vertical to be producing our own powders is there's a really well-established supply chain for the billet material. I mean, we can source 61 aluminum very easily. There's a huge 100-year-old supply chain there. And so there are a number of competitors out there that we also see as partners, and we work with them a lot. Praxair, Carpenter, Valamet, these are good suppliers for us so that we have multiple supply directions, but then also, somewhat competitors as well. But there's a large enough growth in the market that we're seeing more and more powder suppliers. We're seeing more and more supply chain solidification. And it's important for us in that there was really only one aluminum supplier in the United States that was doing any real volumes. And so we want to help supplement that so that we have 2, because all of our customers were saying we at least need 2 in the US. And there are others, there are some in Canada, there are some in Europe, but we're really looking to establish ourselves as an aluminum supplier in the United States as well, out of Colorado.
Perfect. Perfect. Thank you so much, Jacob. Anyone who had a question who wasn't able to get answered or a question that's very predator specific?
I could just ask, before you go, quickly, I'd like to ask a question about the materials you have. Yes. Are you considering any other materials besides alloys? Are you looking at polymers? And I just want to also point out that we have a big service bureau position in Arizona. It's called Mitsubishi Chemical Advanced Materials. We do a lot in aerospace, defense, and automotive. I recommend that we connect on that side, but I'd like to know about your material development.
Yeah, we started with aluminums, and then we've gotten into quite a few other metal alloys. My background is a metallurgist and a ceramicist, so we're expanding into ceramics before we go into polymers. But certainly we now have nickel superalloys, high temperature nickel superalloys, things like refractory alloys from tantalum to tungsten to rhenium, and a number of contracts to develop those with DoD partners and others. So probably polymers are lower on our list than ceramics and metals, but certainly possible.
Okay, thank you.
Okay, Ryan, go ahead.
Sorry, just same question, but for conductors, because you mentioned antennas.
Yes, so we have some high temperature or high thermal conductivity and electrical conductivity products, both copper alloys that we've developed, aluminum alloys that work quite well and have good conductivity, and others. And that's really where the draw for the, both EM and thermal conductivity being important, we've developed those alloys. So we supply a lot of GRCOP 42 components and developing knowledge to the rocket industry, for example, and pure copper, pure aluminum, 6061 works quite well as well.
Thank you.
Perfect. Okay, with that, we're out of time for this slot, but thank you so much, Jacob. Next up, we have Adranos. Chris Stoker, CEO, will be presenting. The floor is yours, Chris.
Okay, thanks a lot. Can you hear me okay?
Loud and clear.
Okay, great. So we manufacture solid rocket fuel and rocket motors, and you can advance. typically used in space launch and military use. Go ahead and advance the slide. But one big challenge is performance. So performance for solids is sort of been enough to be used. It's launch on demand, and it's sort of tried and true and been around for many years. But our product that we've developed dramatically increases solid rocket performance to a degree that hasn't been seen in nearly 70 years. And what that does for our customers is it provides them an opportunity for payload capacity increase. You can advance one. But also range extension. Space launch payload capacity is important, can also be really critical for military, and we can provide that. Same as range, if you pay attention to the Army or many in the defense industry, it's all about range, and we can provide that to a degree that hasn't been seen for years. So how do we do that? You can advance. So historically, solid rocket fuel has been an aluminum powder fuel, still used today. And for those that are unaware, you can advance. They mix that with, they mix that with propellant that has an oxidizer. And the difference that we're doing is we've developed an aluminum lithium alloy powder that when we put into the propellant, you can advance one, it just creates a lot more gas. And this is chemistry driven. And with more gas, we get much more performance. Advance one. So it's compatible with existing systems because it can be mixed essentially in any form factor. So advance one more. So effectively, it can go in lots of different platforms, give range to lots of different customers. Advance. So we've developed, or we are currently performing $5 million of contracts from the Department of Defense. We're starting a project with an international space launch provider. Advance. We've established manufacturing capability. So the building to the bottom left is where we produce the aluminum lithium alloy powder. And then we ship that to the facility on your upper right, which is a munitions facility that's 500 acres. That's where we make our actual rocket motors and test them. You can advance one more. So this year we did our first tactical scale test, proving out our fuel on a actual missile analog. And the data from that test is very compelling and is going to be a platform for growth for us. You can advance. Okay, so the great thing about solid propulsion is it goes in so many things. So advance. On the commercial side, what we're seeing is that a lot of these small sat launch groups are not getting enough performance from liquid systems. And so they're advertising larger liquid systems, or they're advertising the addition of solid rocket boosters. This is an area where we can have a big impact. We can also have an impact on existing small sat launchers, not so much domestically, but internationally, where we don't necessarily need to develop a new launcher. We just say, switch out your fuel and we'll give you much more payload capacity. Advance. On the military side, hypersonic boosters, tactical missiles, artillery, and a variety of other platforms utilize solid propellant to make things go. So really anybody who's launching anything or carrying something that's launching anything should be interested in this. We can get you more range, more competitive advantage, lighter weight, advance. And the product is very flexible. We can optimize for range, optimize for payload capacity or speed, whatever the customer needs. Advance. So if you follow the news, Orbital ATK was bought by Northrop, Aerojet is about to be bought by Lockheed. And so if you are one of their competitors, if you want a rocket motor, you have to buy from them, which is not attractive for many people out there. And so we've envisioned ourselves as a independent, domestically owned solid rocket motor provider. We have the infrastructure to do that, and we've already received some customer interest. So this is traditional fuel and our aluminum lithium alloy fuel. Advance. Okay, so team, my name's Chris Stoker. We've got additional BD personnel who, most of those come from the space launch side. We've got some supply chain people from large defense contractors. Advance. Brandon Terry is my business partner, a solid rocket motor expert. We've got 2 additional PhDs on the team and 5 MEs for a total of 17 with 2 more to go. You can advance. All right, so we're in the middle of a raise led by Impala Asset Management. They're a hedge fund that trades defense stocks primarily. We're at 13.5 million with 6.5 million to go. And we also qualify for StratFi TactFi and are looking for Air Force, obviously Air Force champions that need more range, that need lighter launch platforms. And the stage we're at is we're ready for prototyping. The model is not to develop our own systems, but to take existing systems and frankly make them better. So if anyone launches anything with a solid, they'd be interested in this. So that's the end of my presentation. Happy to take questions.
Perfect. Thank you so much, Chris. Opening the floor up. Whoever wants to ask the first question.
I think Joe Sabre has a question about solids only versus hybrids. We are not doing hybrids, just solid.
Yeah, Chris, really interesting technology. Just clarify a question for me. Are you interested in producing the propellant and new rocket motors, or just interested in using your propellant in existing solid rocket motors?
Oh, definitely new as well. Yeah.
Okay.
Definitely new and too. It's just the existing is a little bit easier path to adoption in terms of time, but there could be new programs that are enabled with our product.
Okay. And do you have the expertise in-house in terms of designing the rocket motors?
Yeah, we do. We're hiring people from big contractors. They start this month on the propellant side, and we've got hardware people that can help us design the hardware, and we've also got the ability to manufacture.
Okay, thank you.
You're up.
Yeah. Actually, you have very unique solutions on the global stage. Is there a possibility that your company can do business with companies or entities in overseas, especially with U.S. allies?
Yeah.
Is it possible?
Yeah, we just got approved, ITAR approval from the Department of State for a project we're doing with an ally right now. And it was a pretty easy process. I think there are certain countries where it would be a little difficult, but I actually see potential in the early adopters being overseas. That's where we're getting a lot of interest.
Maybe we can chat later, please. Thank you.
Awesome, would love to.
Perfect. Thank you so much, Chris. That was fantastic. So up next, we are going to have Aerodynamic. Matthew Grachik, the CEO, will be presenting. The floor is yours.
Thanks so much. My name is Matthew Grachik, and I'm the CEO of Aerodynamics. We're an aircraft design and manufacturing company founded to commercialize our radically different VTOL aircraft design that we call Transwing, which folds its wings in flight to transition between rotorcraft and fixed wing configurations. When was the last time somebody claimed to have a truly novel aircraft design? Well, unless you've seen our aircraft and are familiar with it, you'll be seeing something unique today, I guarantee you that. Next slide, please. So-called advanced air mobility aircraft have the potential to disrupt just about every segment of the transportation industry, but it all depends on having aircraft that can accomplish these missions. Slide. Next slide, please. Thanks. And the U.S. drone delivery market is already significant and growing quickly. The defense market for unmanned aircraft is larger today, but growing more slowly. VTOL aircraft manufacturing for commercial applications is expected to overtake the government sector in 6 years. Commercial, actually, next slide. So when you look at our transwing design, they have several key advantages over other VTOL aircraft designs, including needing just 1/3 or less of the ground footprint of other VTOL aircraft with a similar wingspan, about twice the range and more endurance for any given payload and energy source, faster nominal cruise speeds, greater payload capability, and greater agility and stability during takeoff and landing. And this is especially critical when landing on a dynamic surface like a ship underway that is pitching, rolling, and heaving with a crosswind. Next slide, please. We're leveraging the advantages of our transwing design to target missions that are time sensitive, involve high value cargo, and have destinations that are difficult to reach. Our initial target markets include military applications, civil maritime logistics applications, and industrial applications. And we match our aircraft advantages to market need that value those advantages most. Next slide, please. And so in those areas, we have significant traction. We have signed a contract with the US Navy for logistics aircraft to deliver critical repair cargo to ships at sea. We are having active teaming investment negotiations at very high levels with two of the largest US defense contractors, and are negotiating an investment and order of a significant quantity of aircraft with one of the largest international shipping companies, and are having active discussions with one of the largest telecommunications companies about a bespoke version of our aircraft to serve as an emergency communications relay platform. And it's important to note that every one of these opportunities came in unsolicited. There's tremendous demand for the unique capabilities of our aircraft. Next slide, please. Now, our Navy contract is worth describing in more detail. In early 2018, the Navy conducted a study and found that 90% of the critical repair cargo that were delivered by V-22 and H-60 aircraft weighed less than 50 pounds, and 80% weighed less than 10 pounds. So they launched the Blue Water Maritime Logistics Unmanned Aircraft System, or BWUAS program, to find out, or to find an autonomous VTOL aircraft that could fill this critical need and free the manned aircraft to perform other higher value missions. And after a 3-year competition evaluating more than 65 different aircraft designs, the Navy awarded our company a contract to deliver 3 demonstration units in June. And if they like what we deliver, and I think that they will, this contract can go straight to a sole source non-competitive bid follow-on contract for more units and larger variants. Next slide, please. In terms of our intellectual property, we have 3 granted and 5 pending patents protecting the entirety of the transwing design. And our core patent has 25 apparatus and 5 method claims, and was authored specifically to stand up in defense in the face of litigation. And the uniqueness of our aircraft design provides several paths for additional patent protection that are not relevant for other VTOL designs because they are dependent on the unique aspects of the transwing design itself. Next slide, please. We have an excellent leadership team, I think, with experience launching breakthrough technology solutions, pioneering new markets, and developing novel aircraft designs at scale. Our management team has helped take several companies from concept through exit, generating billions in returns for investors and leaving a dent in the universe. Next slide, please. So ways to engage with us. We have just opened a safe note round for up to $3 million to allow us to capitalize on some of the opportunities immediately in front of us in advance of closing a larger round, which will be a price round, which we expect to close next April. We're also interested in connecting with people within the US federal government who believe that our transwing design might be a fit for programs they're working on. And finally, we're interested in speaking with more US defense prime contractors about emerging teaming opportunities and existing teaming opportunities. Next slide. That's it. So I appreciate your time and attention and the opportunity to share our vision and plans with you and invite your questions.
Absolutely. Thank you so much. Dana, the floor is yours.
I'm probably not the only one on this panel thinking this right off the top of our head. Do you have any plans to maybe scale this thing way up? I mean, the novelty here is the wing configuration, right? Is there anything stopping you from doing something that could be manned?
I would let our engineering leadership answer that, but no, I guess the shorter answer is no, and that's the question we get most often. You know, there's huge opportunity at the larger scale, and we are investing a lot of money and time on proving or doing that analysis, I should say, in order to be able to prove whether it can be done or not, and to what scale. So specifically, we're conducting a study right now at the 6,000 to 12,000 maximum takeoff weight scale for a particular opportunity that we're working on with a defense prime. And you know, we're not sure where the boundary is, but we're keen to find it, and we haven't really, you know, found that barrier yet.
Okay, thanks for that.
Yes.
Perfect. Joseph, the floor is yours.
Hey, yeah, thanks. So impressive. I really like the airframe. Curious if you're working on any sort of beyond visual line of sight capabilities. You know, I think that
Yes.
yeah, go ahead.
Well, yeah, I mean that. So our one project we're working on a DoD opportunity is for a Group 3 light sub 330-pound gross weight vehicle that can carry a 50-pound payload, 300 nautical miles plus 30 minutes loiter on station. So we'll have a genset on board that won't be all batteries. So now, you know, once we're at 300 miles, nautical miles, that's pretty far. Obviously, that all has to be beyond visual line of sight. So full autonomy, detect and avoid, precision landing are all technologies that we need to incorporate into our design and our aircraft. Our strategy with that is not to build those things internally in-house. We think there's some great companies working on great solutions that we can integrate. We're actively having those conversations and sort of fielding those, doing that testing now. But yes, so we do need to have the ability of doing BVLOS sites and have all the other nuance. It's not just flying BVLOS, but also what do you do when the bird encounters something it didn't expect or loses comms? I mean, all of that has to be rolled in, and that's all stuff that we're working on.
Yeah, thanks. Hey, I appreciate that. And you know, it makes me think if you combine this with like an iris automation camera, you've got a great setup there. I had one other question I wanted to throw at you. You know, I think the thing I really like about the airframe is you get the range of a fixed wing and you get the vertical takeoff flexibility. And I see the ship-based launch use case. I was wondering if you had other use cases in mind for this.
Sure. Well, you know, first off, you know, we've built and flown various iterations, different designs from 4-foot to 12-foot, a little over 12-foot wingspans. We've flown hundreds of flights. We have 2 flight computers we're maturing on the platform for different market segments. Other use cases include, like with our the global shipping company that we're partnered with. There is they are. I didn't talk too much in the slide about it, but so they have over 130 ships. They need to be able to deliver payloads to and from their ships underway at sea. They're one of almost 100,000 ships like this that need this capability, large oil tankers, bulk transport shippers, and things like that. So that is definitely, there are many use cases that are in addition to simply landing something for the Navy for critical repair cargo.
Perfect. So Dash, the floor is yours for the last question.
Sure, thank you. Great presentation. Just a question on, I say the Navy application, but have you looked into the app through AppWorks and through the air race ICO and stuff? Because I believe you said that you have flown different iterations of these aircrafts. And yes. So have you looked into the AppWorks program to see more about participation? Because we are interested in looking into electric propulsion and the autonomy side of it. So
yeah. So right, we're raising this $3 million safe note now to, you know, in advance of closing our price round next year. Because we're faced with these kinds of opportunities that we're not enabled to pursue them all. AppWorks has certainly been something that we've been tracking. We participated early, sort of in a more of a passive way, but we've had some real tangible opportunities that we've wanted to pursue. So we had to focus our attentions, and we want to be able to broaden that focus and open the aperture there. So we would love to, you know, very much get more involved with the Air Force and AppWorks and SOCOM and SOFWorks. There are lots of opportunities like that, as well as in the commercial space. So we're kind of faced with an insurmountable opportunity right now, we feel, and we need to to prioritize those. So I'd be very interested in talking with you more about specific things that you might have in mind and ways that we could leverage what we've got with what you're working on.
Sounds good. Thank you.
Perfect. Perfect. Thank you, Matthew. That wraps up that slot. Next up is going to be Scope AR, and Greg Scott will be presenting. Greg is the Director of Sales and Solution. Greg, the floor is yours.
Pardon? Yeah, bring an umbrella for.
Okay, if Greg isn't on yet, because I'm not seeing him, we're gonna move forward then with Viz AI, and then circle back around.
I'm showing Greg's in as an attendee. You gotta upgrade to a panelist.
Oh, okay, so he's here. Oh, perfect. So let's upgrade him.
Is Dave Gosh here?
So was Greg there, Usher, or did you want me to start?
Yeah, so let's have you go, David, for now, and then we'll circle back around to Greg. So next up is Viz AI. Dave Truck will be presenting. He is the Executive Vice President and CTO. Dave, the floor is now yours.
Okay, great. Well, good afternoon to everyone, and thank you all for attending. I'm really pleased to be able to speak to you today about our exciting and unique 3D technology that has actually been 20 years in the making. We're now commercializing the capability in 3 key chosen areas, that of inspection, autonomy, and biometrics. Next slide, please. So what's really important to do is to start to understand what is the problem of 3D. Everybody's using that language, but are we truly 3D? I would maintain the answer is no. In actual fact, for decades now, our capture and conversion of the world into 3D data has actually been based on 2D data sensors. So our time of flight sensors or photogrammetric techniques, other approaches provide actually very limited information about the actual objects in the world, and more importantly, the characteristics and properties of those objects. A reflection back doesn't tell you what really is the object. So what we do is we spend considerable amounts of human and computer time to make sense of the data, to convert it into these more usable forms, such as the shape or a series of shapes that define an object, the identity of that shape or object, its measurements, its movement, its orientation, its component parts, etc. So we show you an image here taken from our actual sensor and our approach. And I just wanted to point out very quickly 3 key elements in here to just keep in the back of your head. First of all, is that all objects in the scene are understood. So if you look at the image, you could see we actually have the shape of all of the objects there. Second, in this case, we've chosen to only show you the surface information from the normals, which are color coded. So things that are green are pointing straight up. Things that are red are pointing to the left. Things that are blue are pointing towards you. So you could see the different color coding here is representing actual surfaces and the information about the surfaces. And lastly, we've chosen to show you just in this particular image that we can give you movement information. So we've chosen to isolate the object called car out of that particular set, and we're able to give you its distance and velocity vectors, and other information is there. Next slide, please. So why does this matter? Well, the simple answer to me is that the analysis that can be accomplished using the 2D data is actually limited by the sparseness of the data that's captured. It's sparse in 2 elements. It's sparse in quantity and amount, and it's sparse in richness of information. So point clouds, time of flight values, intensity values can only go so far to give you a real-time understanding of what's there in front of you. We see many key major areas of concern in the world today, and we're focusing on 3 of those that we think impact the world in general. So we see this as very ubiquitous in nature. The integrity of our national infrastructures, a real key issue right now. Safety of our individuals from all kinds of things around autonomy and autonomous vehicles and other issues there. And also, as recently we've all experienced, the health of our individuals. Each of those areas of concern in our mind require true 3D information, but the current solutions are limited by the physics of what they're getting from the 2D sensors. And so these sensors are fast reaching the limits of providing dramatically more and varied real-time information. Next slide, please. But what if you could obtain this new set of information, such as angle of orientation, surface normal, slope vectors we talked about there, as well as intensity and RGB values that we get from some of the more traditional sensors? We've shown you in the opening slide that we have a plethora of physical information about surfaces we can use to analyze. And we don't have time in today's session to detail out really the aspects of our technology. So rather, I think I'd best show it by just describing a few of the commercial capabilities we already have. In this case, in the inspection area, we can take an acquired image through our sensor. We can process that image. We can immediately tell what is blistering and rust, how much of it, what its measurements are, what its values are, and more importantly, we can also standardize that under an ISO standard automatic classification. So basically, in essentially real time at the time of capture, one already has an analyzed answer, which is significant and able to dramatically change the inspection process. Next slide, please. We've also shown you that we can do tracking. In this case, we are showing you and demonstrating we can do drone and vehicle tracking and identification. So these are particular types of drones. On the left is actually an image below the horizon. You can barely see the drone on the left, on the right, but we actually can see the image, quantify it, and provide that information. Next slide, please. And finally, we have a significant amount of biometrics that is also commercially available. So we do have certified facial recognition and fingerprint identification capabilities on here, and then a whole series of things more. So behind these now, if we turn on, next slide, please. So what we also have behind these is other proof of concepts that we have now already moved up to the near commercial readiness side. So we have demonstrated that we can do things such as emotion detection, metrology. This is a single quarter scanned at 17 feet. So just another key element. We are a passive sensor, and optics help us get more pixels on target. So we can see things at very large distances. So this is a quarter scanned and created in 3D form from 17 feet away with high precision. Next slide, please.
30-second warning.
Thank you. We've also done stress and strain analysis. We've gone through an endoscope inside the interior bodies and can give significant information about the interior vessels and that. Next slide, please. And we've also done quite a bit of work on wound care. So we can actually track and monitor and give you assessment of the body's recovery after wound things. Next slide, please. We have a strong management team, starting with our founder, Blair Barber, who's on the call as well, who's really created and spurred the technology and had taken it over the majority of the 20 years. Next. Paul Ham with significant commercial experience. So we have our foray into the commercial area. And finally, the next slide, please. That's myself, a well-seasoned veteran, which just means I've been around the block a long time in the energy sector and that for over 40 years. And finally, the next slide, please. So our real ask of the panel here is that we are really seeking commercial and military partners that we believe can help us create bespoke solutions to some very unique problems. And with that, that should close us off.
Perfect. Perfect. Thank you so much, Dave. We are going to open the floor up now for any questions for Dave. Sure, Joseph, go ahead.
Hey, Dave, thanks. Great presentation. I just want to be clear on what the product here is. There's a hardware component, a sensor of some sort. It looks like a couple AI models, one that actually builds a model of what it's seeing and another that's able to identify objects. Is that correct?
Yes. So what we offer is we offer a sensor, as you mentioned, the hardware component. And then we have a series of software capabilities bundled under something we patented and called ShapeOS. And this is our ability to interpret our signal in real time and create those property values that you saw, for example, the normals of the surface and that, and understand that we have that at each and every pixel in the sensor, so that essentially with one shutter exposure, and I'm just using that language loosely, we get the entirety of the scene, and it's more about just processing various aspects of that depending on the use case. So from the ShapeOS software component, we can create a whole myriad of different application sets.
Gotcha. Thank you.
Perfect. Dash, you're up.
So Dave, the question was on the slide where you showed about a drone detection system. That looked more like a drone detection system. Was that using a camera, or what was that?
No. So that is using our sensor. Remember, I said one of the added values of our approach is that we still can give you intensity and RGB values as traditional cameras do. That is actually not what we use in the majority of our approach of interpreting what's in the scene. We actually use these other properties I mentioned. It looks like a camera because it's optically based, but the actual sensor and a lot of the stuff. Just one more to also answer that other question. We also do take advantage of AI approaches with our data and use those to augment. So we have a lot of mathematical techniques that are what I call the first principles based on the real physical properties of the signal. And then we also do use AI approaches to augment our understanding and do that, because they work well too.
Perfect. Ryan, last question.
Thanks. Maybe I missed it, but are you able to do this for video feeds, or is this for still images? What's the latency? Processing latency.
It's essentially video feed. We've done. It could be a single instance, a single opening in the shutter, but we also have processed. So for the tracking and everything, that is all essentially video feed, 30 to 60 frames per second. Blair, you could probably qualify that a bit, but I believe we're in that kind of range.
Absolutely. It's within a frame time. You can get the updated tracking, the velocities and information.
So I'm trying to get a sense of how much processing is needed. I mean, do you have an A100 sitting behind that doing that, or can you do it on a Snapdragon? What do you need to process in real time?
We're typically using a laptop right now. We are using some of the GPU to do the overall processing, but it's a very light, even though we're getting full three-dimensionality, our computer understands the slope vector between the angles, understands these kind of things, which allows the processing to be much, much quicker.
Okay, thank you.
Perfect. So anyone else who has a question, please feel free to chat Blair or Dave. Next up, we have Scope AR. They are ready and gonna go now. Guys, the floor is yours.
Thank you. Dave Gosh, just a quick sound check if you don't mind.
I'm great.
Okay, excellent. Well, we're going to stick with the Daves. We're going to stick with 3D. Dave Gosh, I lead global sales and solutions for Scope AR, joined by Greg Scott, who runs our air defense business as well as medical equipment. We are an industrial software company focusing on 3D visual knowledge, but with the secret sauce of using augmented reality. Our objective today is simply, we're looking for target programs to continue expanding our footprint in the industry and work with your innovation teams to realize new forms of productivity, quality. So this is absolutely an operations play. Next slide. So imagine for a moment, what if all of your operational people, those in the manufacturing floor, out in the field, what if they had the knowledge already to do anything they needed regardless of the domain, and had that information available. So that is the mission next of Scope AR, is basically digitizing and bringing immersive experiences to these individuals as they're doing work or from a training perspective. Next slide. So my background, actually, I'm a career industrial technologist. And coming to AR, what this meant for me is instead of making better machines and control systems, it's all about the people now, helping people do work better and provide new efficiencies to those operations. Our founding team, which is on the left here, you've got a CEO who wrote the first software stack, a chief customer officer who's a global curling champion out of Canada, and a creative services VP who is a well-known sports documentarian. Next. So the problems that we're looking at, again, operational efficiency, to do with as assemblies and manufacturing becomes more complex, especially with the addition of composites, massive amounts of epoxy-based fasteners. How do you avoid rework? How do you stay efficient? And then, like everything with industrial operations, it's about insights, it's about traceability. Next. So let's take a look at these different layers. Training, I mentioned, building things, maintaining them in the field. Let's go. Next. So for example, Lockheed Martin, able to achieve 0 errors on every program that they've launched using augmented reality. Uses a combination of wearable devices. As you can see, there's a Microsoft HoloLens here, as well as mobile phones, tablets, massive reductions in efficiency. And Lockheed today has over 30 content authors licensed, as well as thousands of end users. Next. Other companies, Johnson & Johnson, they've gone digital on training, launched their latest medical arthroscopic surgery robot using all AR for training for their field team. Next. And lastly, Danaher, again, digital training, unable to travel during COVID, massive cost savings, both from internal travel as well as customer support. Next. So across the board, we're working with, tend to be the monsters in the industry, aerospace defense, many different types of manufacturing, as well as life sciences, medical equipment. Next. So how do we do this? Our software is called WorkLink. In fact, you can go to App Store of choice, download WorkLink by Scope AR, touch on demos. You'll see about half a dozen demos there. There's actually 2 personalities to the user side of the app. One is these prepared work instructions, being able to work autonomously and have traceable work, as well as this remote connection side, which is real time. How do you tap your experts who, instead of having to go to the factory floor maybe to deal with a quality problem, can be at their desk, can be remote, and we're basically amplifying those experts. Next. All right, next. Okay, so there's a video in the deck, which you can check out after, but that's okay. Let's just keep going. So as you saw in some of those examples, we're basically, like on the left here, we're adding holograms to existing assets, helping people understand what to do next, where to put their hands, how to unconnect something, how to assemble something, grab the right connectors to assemble. What's surprising though is the majority of the value is extracted through these other modes where you can literally change the mode, put an entire asset in front of you. This is a 3D printer here in the middle. And so now you can experience an asset. So think about having thousands of field people being able to train without a device, without a lab, without a training lab, or to be able to immerse themselves in a 3D experience right on an airplane before making a field call. Next.
30-second warning.
Thank you. Perfect timing. So what you're seeing here is this then ability to create these new experiences. This is a new medium. Take that CAD, convert it into meaningful visuals, execute those instructions, be able to connect and amplify experts, and of course, analyze what's happening after the fact. Next. our secret sauce. This is a new medium, getting this content created by the masses. So your tech pubs people, your operational instructional people, we've solved the problem of a very intuitive no-code environment that is also extremely capable. This is what's enabling these major companies like Lockheed, Northrop, Oshkosh Defense to scale. Next. So we're here, our expertise is available for you. As mentioned, we're looking for on-target programs, more Lockheed Martin, more Sierra Nevada, Oshkosh, you name it. Those are the types of programs we're looking to engage with. Open to questions.
Perfect. Thank you so much, Dave. All right, the floor is now open. Feel free. Joseph, you're up.
Hey, thanks so much. Really impressive. And I love the AR videos really lend themselves to a presentation. It's great. Curious if you have a real world example of how long that create process takes, starting with nothing, building your instruction manuals, training your users, organizing all your experts, and then going from nothing to up and running.
Yeah. First off, I'll send you our aerospace defense deck if you hit me offline. We have examples from Lockheed Martin where that's how they document ROI. So we spent 8 hours creating this experience, and we saved 4 shifts on the production line, and that's for like early assembly. Typically, once somebody's up to speed on this, which may be about a 1-month process, they're making new experiences each week. Which is really common across medical and defense. And obviously, these are like making movies. You can make a quick one in 1 minute, or you can spend months on that movie. But the efficiency is the key to scale here. That constant cost of acquisition of the medium. It's too quiet.
Well,
Yeah.
I don't want to hog, but I can ask. I do have other questions. Curious what your business model looks like. So we've got some hardware. We've got onboarding, of course, is going to be probably the lengthiest process right up front. You've got ongoing support, and you're trying to scale your user base. Just from your perspective, where's the what's the biggest revenue driver on your side, and where are you trying to scale?
It does come down to, well, 2 things. One is landing new programs. The other is scaling those programs. So getting a number of, especially in aerospace defense, our clients then author everything. They deploy on premise. So being able to scale those teams, we tend to do a lot of workshops, training, and have really intimate relationships with those clients. On the adoption side, it's, this is still a new medium. It's not always recognized as an enterprise level, an investment that's going to save money. So there's a lot of proof points in proof of value and proof of experience from the teams that will need to implement it.
Perfect. I think that wraps that up. Thank you, everyone who participated. Thank you, Dave. Thank you, everyone who participated, all the panelists, all the companies who participated in the aerospace session. Now we are moving forward. We're going to keep chugging along to the defense session. So joining us for the defense session now is Darshan York from Cityside Ventures. Also joining us is Derek Goeres from Aerovironment. Felix Knudsen from the U.S. Air Force will be joining us, as well as Ilona Altman from the U.S. Air Force. Dash will be staying on from AFWorks. Stephen Potter will also be staying on from the U.S. Army Reserve. Dana Jensen is staying on also from the U.S. Air Force, and Joseph Anger will be staying on also from the U.S. Air Force, and Dusty Grogan is joining us again for the third and final panel. I'm going to ask everyone to quickly introduce themselves. I know for some of us it's been the third time, but still for those who are joining us just for right now, It'd be good to give a quick introduction. Without further ado, I'm going to go in order of the list. Daron, if you are on, please introduce yourself. Alrighty then. Next up, Derek. Derek, if you're on, please introduce yourself.
Yeah, hi, Derek Gord's happy to be here. I'm a director of BD for AI and ML programs at AeroVironment. Also work closely with AV Ventures, came out of Army Special Forces and CIA.
Awesome. Thank you. Felix, you're up.
Hi, I'm Felix Knudsen. I work on the Disruptive Technologies team in Air Force Futures. So we look at the Air Force future design, future force designs of 10 to 15 years out. And also, Asher, I think you mentioned StratFi and TACFi earlier today. So we also play a role in that, in aligning those with our strategic priorities.
Nice, awesome. Ilona, you're up.
Hi, my name is Alana Ullman. I'm a portfolio analyst and I study autonomous technology for the Air Force. Happy to be here. Thanks.
Perfect. Tash?
Hey, I'm working with AppFox as Senior Operations Research Analyst, and we work with emerging technologies and eVTOLs and anything on the AI autonomy side and everything. So anything that is focused on emerging technologies, AppFox is interested.
Perfect. Stephen Potter?
Hey, good afternoon, Steve Potter with the 75th Innovation Command, and our organization augments Army Futures Command in technology scouting and analysis of emerging technologies. My specific focus is on the portfolio, including robotics and autonomous systems.
Perfect. Dana.
Hey, Dana Jensen, Senior Industrial Policy Analyst with the Air Force's Office of Economic and Commercial and Economic Analysis, primarily focused on advanced air mobility and particularly the supply chain underlying it, the enabling technologies like advanced propulsion, composites, and that kind of thing.
Perfect. Joseph Enger.
Hi, I'm Joe Enger. I'm the 56th Fighter Wing Innovation Superintendent here at Luke Air Force Base, Arizona. We're looking at bringing in technology to help improve aircraft production and pilot training.
Perfect. And last, Destry Grogan.
Yeah, Dr. Destry Grogan. I work for the synthetic training environment cross-functional team for AFC down in Orlando, Florida. So I'm the director of technology development, working on synthetic environments and training inclusion in those environments.
Perfect. Thank you, Destry. Perfect. So we are going to kick it off with Nuburu. Mark Zedeker will be presenting. He is the founder and CEO of Nuburu. Mark, the floor is yours.
Thank you, Asher, and very nice to meet all of you today. We started this company back in 2013, developing the technology, got funded in 2015. It's all private funding to date. And what we're going to talk about today is the future. This is an emerging technology. In approximately 2013, I noticed that this technology was unique and had some very tremendous benefits compared to what's out there today. So next slide, please, Asher. On the commercial side, we have demonstrated repeatedly that this technology has tremendous advantages in e-mobility, in energy storage, and electronics. And that advantage is that we can weld materials such as batteries, battery packs, aluminum, titanium, much better and much faster than the conventional techniques that are out there today. What that does is it dramatically improves the reliability of these batteries. In addition to that, the performance of these batteries by reducing the inherent losses in these batteries due to poor welds. We see better current capabilities, less heating, and longer lifetimes. This also applies to any type of electronics. Electronics typically and other thin type materials. And the reason why this works is that the blue laser technology is quite unique. Blue, as is in my background, is the color of the laser that we build. That light, that wavelength, is absorbed very heavily by all materials. Much, much better than its infrared counterparts. As a consequence, it's the ideal solution for welding batteries and battery packs and electronics. But we've also recently started looking at directed energy and what could you do there with a blue laser technology. As I mentioned, all materials absorb the energy more efficiently than the infrared source. The direct energy weapon shown on the far left is the system that's using a roughly 1 micron wavelength source. And the absorption differences of that white coating it has can range from a few percent for the infrared source to 10, 20, or even 30% for the blue laser source. What that means is that you need less power on target to do damage. From a system point of view, it's ideal in terms of swap, size, weight, and power. If you need less power on target, guess what? You need to produce less power at the origin. Or if you have even higher power or higher resistant targets such as hypersonics, you now have the ability to address those with very, very high power laser systems. The other area where we've recently started exploring what these lasers can do is additive manufacturing. We have introduced recently with a number of demonstrations a blue laser into an EOS M100 machine. And we've immediately determined that it's much, much better solution than what's out there today. We also have plans for scaling that to very large scale additive manufacturing. Next slide, please. So I'm just going to cover in order what I just talked about. In terms of DEW, we have looked at the shorter wavelength. We've looked at the ability to transmit that shorter wavelength through the air. That's one of the key aspects of trying to attack a target. What we've discovered is that the blue wavelength transmits just as efficiently through the air as the IR. But there's two major advantages: the absorption, as I've mentioned, and also the ability to put a smaller spot size on the target for a given beam director. What that smaller spot size means is faster kill times. And as a consequence, in the link studies we've done, we see kill times for equivalent laser powers factors of 2 or greater than the infrared. We've also recently completed an AFWERX phase 1 SBIR. And here we were doing some tests on counter drone. As you can see on the right, we can essentially blind the drone at tremendous distances. In fact, we can build a handheld system that can dazzle that drone at ranges in excess of 30 miles. We also can build relatively small systems that can completely fatally damage the drone. Again, because of the high absorption characteristics of the blue light on most materials, the time to kill is dramatically reduced, and the size of the system required to do damage is dramatically reduced. In the case of many of the counter UAS systems out there in the infrared today, they're looking at nominally 10 kilowatts of laser power, and we've been able to show with just 1.5 kilowatts of laser power, we could do the same job. Next slide, please. This is an example of the battery welding that we're able to do and the bus bar welding. As I mentioned, the blue laser light is highly absorbed by copper and by aluminum. As you can see in the lower left corner, an absolute pristine weld of a battery pack. That's to be compared with what they use today, which is primarily ultrasonics. And that results in relatively poor welds. And in fact, those welds require a lot of space, which reduces the energy packing density of the battery. So we can improve the energy packing density, we can improve the reliability, and we can improve their performance. Aluminum, same thing. And then in terms of bus bars and hairpin, same thing. Hairpins, by the way, are the little electrical wires that are in the motors that make it work. Okay. Today, we've distributed over $2 million with the Beta laser sales. Approximately 80 companies are working with our lasers today, and we're currently in our product launch phase. Next page 2, please.
30-second warning.
This is an example of the EOS M100 machine with the blue laser integrated in it. On the right is some metallurgical analysis of stainless steel on the top and copper on the bottom. In the center is experimentally determined advantages for using a blue laser compared to an infrared and the improved printing speeds that can be accomplished. And in the case of copper, we were able to enable this small system to be able to print copper, and it could not when we received it. As a consequence, the printing ratios for this system are very, very high when using copper and a blue laser. Next slide, please. This is our team, myself, the founder and CEO, and all of our executives have over 30 years experience in building companies, founding companies, and growing companies. We have a strong R&D presence as well as a strong operations group. Next slide, please. So in summary, we've got significant commercial traction demonstrated in the battery manufacturing segment. We've just started talking to DoD folks this year. We've got multiple customers we've engaged. We're seeking partners and funding for expanding our involvement in DoD projects. So we'd love to talk to anybody who's looking at future technology. And last slide, please. Next slide, Asher. This is our facility. As you can see, founded in 2015. It consists of R&D, manufacturing, sales and marketing. It's about 30,000 square feet where we're working on applications in welding, 3D printing, and defense applications. Thank you very much, and I'm open to questions.
Thank you, Mark. All right, we're gonna open the floor up. Feel free, whoever wants to kick it off. Yep, Dash, you're up.
Hey, Mark, I saw your slide in which you mentioned about your phase 3 MOU that you're looking for. Basically, I think you're looking for a TPOC for that. Who are your potential Air Force end users that you feel you need to reach out to? Because I could help at that side.
Okay, we have reached out to a number of end users in the Air Force, and what we're really looking for is some early development funds under that phase 2 contract. And so we have to find someone in the Air Force because it's an AFWERX program. And we've reached out to AFRL folks. We reached out to both the folks down in Albuquerque and the folks out in Wright Pat. But we also would be open to talking to others. If you may know some more, we can look for. We have not yet been able to secure that MOU.
Sure, I can. I'll drop my email and we can connect. I think I can help you find the right person.
Thank you, Dash. Appreciate it.
Perfect. Felix, you're up.
Hey, Mark. So a lot of the comparisons you made were to IR lasers. I was wondering if you could compare your blue laser to a high-powered microwave. So when would your solution be advantageous or maybe not as good in comparison to a high-power microwave when it comes to something like base defense?
So are you referring to using high-power microwave against personnel or against equipment?
Against equipment. So UAS as an example. Or I think you also mentioned, I think you mentioned missiles in your briefing.
Yeah, the missiles is more long-term. I mean, that's years of development that have to be done. The counter UAS, within 2 years, we can have an operational unit for testing. And we believe, based on the testing we've done so far, first off, we can reach out at distances microwaves could only hope to, and that is we can start dazzling at over, 30 miles, which means that we can take away their visual acuity, their inability to identify, locate targets and waypoints, and then they have to go entirely on inertial or GPS. Combined with a radio jammer, you can knock out that guidance, and then combined with the ability to do a fatal damage when it gets in close. So you have a multi-layered defense against UAS. And that is what we're looking for the MOU on. I should comment.
All right, thank you.
You're welcome, Felix.
Perfect. Anyone who has, I think you have one question at least in the Q&A. Feel free to take a look at that, Mark. We're gonna keep this moving along. Next up is Clive Cook from Precursor. He is the CEO of Precursor. Clive, the floor is now yours.
Excellent. Thank you, Asher. Just want to make sure you can hear me.
Can hear you loud and clear.
Okay, perfect. Thank you. This title slide illustrates the energy of the most consequential recurring geospatial phenomena, space weather, and earthquakes. Earth is constantly subjected to massive changing energy releases that we cannot see from the sun, the Earth's magnetic field, and recurring geospatial events such as solar storms and earthquakes. The Earth and atmosphere, known as the geospatial environment, is characterized by a dynamic electromagnetic energy profile that has profound impacts on what we do in space and on the Earth. All GPS services are affected by changing geospatial conditions. The electric grid powering our homes, cars, and future is affected by the changing geospatial environment. Space launch, satellite communications, and advanced PNT applications are critically impacted by the geospatial environment. To the space warfighter, the intelligence community, defense organizations, and national security, the most important, elusive, and often unknown element of the geospatial environment is actionable information. Time. What is happening now? When will this change? How do we know when it will change? Precursor provides actionable information for geospatial intelligence. Next slide, please. Time is the most difficult and elusive problem associated with space weather and earthquakes. With no useful real-time information or actionable advanced knowledge of the geospatial environment, preparedness is not possible. Operations or missions are at risk of error or failure. Costs cannot be mitigated, and responses are chaotic. The space warfighter, the intelligence community, defense organization, and national security are all directly impacted by the changing geospatial environment. I quote from one of the conversations we had during our contract with US Space Force. Space weather capability is 50 years behind where terrestrial weather capability is today. Today, there is no earthquake forecasting capability that can tell you days or weeks in advance that a small or large seismic event is imminent. Today, this everyday lack of location-precise, time-specific information costs tens of billions of dollars each year. A single significant space weather event or a catastrophic earthquake can cause trillions in damages and loss of life. There is no timely or actionable information, severely limiting assessment, decision-making, situational awareness, and action. Next slide, please. Precursor delivers two first-of-a-kind capabilities, space weather nowcasting and earthquake forecasting, that provide actionable information by revealing the changing, dynamic, time-specific nature of space weather and earthquakes. Precursor space weather nowcasting is a unique, extremely high fidelity, real-time 4D, time plus volume, space weather technology. It is not a model, it is what is actually happening in real time. Precursor's capability assimilates all perspectives in real time using a sophisticated machine learning technique to deliver a 1,000 times gain in both spatial and temporal resolution. Precursor's earthquake forecasting uses a physics-based time series machine learning technique to identify the changing electromagnetic thresholds, anomalies, and event sequence that always precede a tectonic earthquake. Precursor earthquake forecasting delivers the accurate location, magnitude, and time at least 72 hours in advance of an earthquake. Next slide, please. Precursor gathers unique physics-based data from new and existing satellite systems and ground-based sensors to assimilate all perspectives in real time. We then make use of an advanced machine learning techniques to accurately report the real-time map of the ionosphere and to forecast seismic events. These are not models. They are measuring what is actually happening, the changing energy profile of the ionosphere and the buildup of energy prior to earthquakes. Our machine learning approach combines multiple techniques to determine with the highest fidelity in both location and time the changing dynamic geospatial environment to deliver space domain awareness. Next slide, please. Precursor's proven capabilities have forecasted over 50 seismic events, 5 separate programs with more than 90% classification accuracy, and demonstrated real-time high-fidelity ionospheric mapping over Northern Europe for US Space Force. Precursor is finalizing opportunities to deploy and operate both our space weather nowcasting capability and our earthquake forecasting capability. We are partnering with a global reinsurance firm to deliver new insights to better assess risk and to introduce new products and services for space operators and businesses operating in seismically active regions. We have a handful of partnerships with leading organizations supporting our efforts. Next slide, please.
30-second warning.
Precursor is a commercial company focused on providing actionable information in advance of important geospatial events. Ultimately, we see ourselves as a financial services firm. We are a first-of-a-kind capability and monopolize value from derivative products. We are in the unique position to take a market-leading position in the plus $50 billion market that includes preparedness and risk management. Next slide, please. Precursor's operational space weather platform is one of the most effective dynamic space weather solutions in the world. Precursor is seeking a PEO for a space weather focused SBIR phase 2 and is raising $3 million in a series seed round to advance the company to the next milestones and begin commercial launch of our data subscription services. Thank you for your time. I'm Clive Cook, co-founder and CEO of Precursor SBC.
Thank you, Clive. Thank you, Clive. All right, so we will now be opening the floor for questions. Whoever wants to take the first question, go ahead. Perfect, Dash. No, Dash.
So Clive, I saw the slides and your strategic, I think, partners or potential, clients and stuff. Have you looked into any federal agencies because you're looking for CBERs and stuff? Have you looked into other federal agencies and what has been the response from that side?
We've looked into a number of federal agencies and are working with a number of federal agencies. The response has been very good. We're working with the Air Force and Space Force, the 557th Weather Wing. We are working with the Navy. We have a CRADA with the Navy for joint development efforts and launch of a specialized satellite. We are working with 3 different intelligence community agencies to introduce our new capabilities for them. And there was one other thing I was going to mention. And we're working with NOAA, specifically the Space Weather Prediction Center, on introducing our real-time capability.
Yeah, I forgot to mention, I was looking for NOAA and FEMA as such to see what their response has been on the disaster response and risk management and stuff.
Well, they want NOAA and USGS, those organizations want to have the ability to provide or to assess the environment and then provide critical event notification information, and we uniquely provide that. They don't really do the risk management side. On that side, we're working with commercial insurance and reinsurance companies to provide that capability for them. So it's a joint commercial and government based. Our focus is on we're a commercial company, so we're focused primarily on the commercial realm, but we have unique capability that can directly help government agencies.
And just to add to it, I saw a slide where you mentioned you put your technology design or the picture of the technology. Is that a specific one, or do you tap into other sources also to get the data?
We have our own unique data gathering or data collection capability, as well as we tap into commercial data sources, as well as different classified government data sources.
Thank you.
Perfect. We have time for one last question, and then we'll be moving forward. All right, we're moving right ahead then. Next up is Title Scale. Gary Smerden, President and CEO, will be presenting.
Great, thank you. Appreciate the opportunity. So I'm going to introduce you to Title Scale and a technology that we have developed, which truly is a breakthrough. I know that's a term you hear a lot, but truly is a breakthrough. And we call it software-defined servers. If you go on to the next slide. So let's first talk about the challenge. We all know it's all about data. We got to get the most out of the data. Military, of course, has known this for years. Businesses have really started to catch on to this in the past decade. Now, data, we process it in computers, and computers have been driven by Moore's Law. Moore's Law has driven the technology industry for the past 4 decades. But the challenge is that Moore's Law has predicted over the past 12 years that computers would be over 200 times higher performant than they actually are. So Moore's Law is dead. But during the same time, data has been growing at this exponential rate. And so there is a huge gap. There's a huge opportunity. That's where TitleScale fits in. If you do one more click. So now the key is doing processing of data in memory. Why is that important? Because DRAM is 1,000 to 10,000 times faster than the fastest flash storage. You know, we don't really know what nanoseconds and microseconds and milliseconds all mean, but let me put it in perspective. If DRAM access is 1 hour, then we're talking about storage being measured in months and years. And that's a huge, huge difference. We got to keep the data in memory. So what are we doing about it? Or what is the benefit? The benefit, if you go to the next slide, is that we get performance by putting and creating systems that are big enough to put everything in memory. We are not yet working actively with the military, but this is a business application that I think has a lot of similarities to a battlefield. And that is the tracking of people at a Major League Baseball game. Yes, cell phones, all these other Bluetooth devices are all being tracked as you walk into a stadium. They can measure within a foot where you are. All of that's being captured. It's anonymous, don't know who the person is, but the movement of this is all captured and then is processed to try to make big analytic decisions on how to have improved performance, how long the bathroom lines are, how can we make people spend more money, happier events, et cetera. Working with our partner in this particular one, it was taking 30 days before TitleScale to do the processing at AWS. After TitleScale, they could process it in 5 days. And also the processing can now even be moved to the location. So out to the field, do it at the stadium where actually you can get to true real-time processing of an individual game. So huge benefits. Go on to the next slides, if you will. So what we have created is the software-defined server. Another click. And then basically what we do with this is that we combine standard servers together, one more click, into a system that is a virtual server, the software-defined server. So standard x86 servers just connected with Ethernet, no change to the operating system or the application, and it just runs. The difference is we now have the ability to create a system that is sized to the data. The benefits of it are huge. I'll touch on that more in a moment. One more click will show you a small list of some of our customers and partners from around the world. Okay, next slide. So the benefit of this is measured in several things. First, performance. We get all the data in memory. Also, a part of our secret sauce is that we have the industry's first use of real-time machine learning within the computer itself. So we do that with built into our software. We are able to drive down costs by using standard servers and the ability from an agility standpoint to create and resize in minutes, make it bigger as required, scale down if necessary, huge agility. And the next thing that we are in the process of adding right now, one more click, is increased reliability and uptime. So we have a technology that will allow us to avoid 90% of failures, as well as recover 100 times faster than it takes today to recover and fix a standard server. So putting to some numbers, one more click into what our customers are seeing. What they are seeing is benefits like 10x better performance, 50% lower cost. One more click, please. Being able to do a deployment that is 25 times faster than they were able to do before. They don't have to do the analysis. They just deploy, measure, and modify as requirement, and reliability and uptime that is 100x higher than what is being seen today. So huge, huge overall benefits in what we are bringing to the customer. Now, let me give you one final kind of view of where we're going in the future with this technology. One more click. And that is, our vision is that systems should be self-optimizing, self-healing, and self-sizing. Now, these capabilities, self-optimizing, self-healing, self-sizing, they've been around for decades with networking and storage. However, standard computing doesn't have these capabilities. What we've done with our real-time machine learning is we are bringing self-optimizing already. We're bringing self-healing with this new capability of Tidal Guard, where we can hot swap a system and basically get this 100x improvement in uptime. And self-sizing is a capability that we will be adding in the future. And that allows a system to automatically adjust to the actual data requirements, which is something that has never been possible before. So go on to the next slide. So let me leave you with a quote here from one of our friends and advisors, and it's Gordon Bell. He's an industry legend, American computer legend. He invented was the father of the mini computer. The Gordon Bell Prize for High Performance Computing is essentially the Nobel Prize for High Performance Computing. And essentially what his view is that these innovations and this innovation layer that we have developed at Tidal Scale is the way that all servers will be built in the future. They can be deployed in big data centers. They can be deployed in a Humvee. They can be deployed in an aircraft, because we're just using standard building blocks as our key to how we put this together. Now, as far as our ask, we're working in the commercial environment today. Ike Nassy, who is our CTO and founder, has done a lot of work in the past with DARPA and with governments. He ran all the software at Apple. He was the chief scientist at SAP, many other great accomplishments. And so we are interested in government funding to accelerate this roadmap. We have innovations that the patents have been issued on it, but we haven't been yet able to fund it. And we believe this is great dual use technology from that standpoint. And the last ask is that our technology is in production. Our third generation is already in production. We're soon going to be releasing our fourth generation. And this is a technology that we know has great applicability for the military, for government applications. And we would love introductions and opportunity to help support that. Also here with me to help answer questions is Dave Ferretti. He's, I know, texting in the chat session. Dave heads up our worldwide sales operation, and so Ike and myself and Dave are all here to answer your questions.
Perfect. Thank you so much, Kay. We're going to open up the floor now for questions. Feel free to just go ahead. Derek, on you.
Yeah, hi, thank you for that presentation. So I'm interested in the application with respect to Major League Baseball. I'm close with the owners of one of the teams. Could you tell me where you're at from a technical readiness level for a deployment to a baseball stadium? Because I believe I understand the value proposition there.
Yeah, so our technology is a core foundation technology. And so in this case, we're working with a partner who basically, they have the application that's actually doing the tracking, and the technology does the tracking of Bluetooth and wireless devices. But the problem is the data is coming in so fast. How do you absorb the data? And then how do you do the analytics on the data in real time? And that's where we come in. We basically have created that technology that allows it to scale to whatever size, whatever granularity of the data that is required. So Circle is the name of that company, and we are we're a close partner of theirs, and they use us for multiple of their other use cases, including baseball.
Thank you.
Mm-hmm.
Just a quick question. When you talk about application in government setting, is it just the same technology, the same way a data center would be using it, the same thing for a government data center, or is there something unique here that you need to do to tailor it to gov?
So the core technology is going to be similar. There is no doubt as we get into specific government applications, I would expect that there could be optimizations that could be made for those. But also, I think the ability, particularly from a government standpoint, the dealing with computers and creating systems of an indeterminate amount of size is a huge challenge right now. It's a big issue for the industry, and being able to address that fundamental is a big opportunity. The second thing is the self-healing can't be underestimated as well. And the reason is that these big systems, which are needed, also become inherently unreliable. And we basically, with what we're doing, we bring reliability back to these very, very big systems.
Thank you.
Perfect. Thank you so much. All right. That wraps up Title Scale. Thank you, Gary. Next up is Luminate GS. Presenting, we have Lev Sadovnik. He is the CEO of Luminate Government Services. Lev, the floor is now yours.
Thank you. Good afternoon. I'm going to talk about augmented reality hardware, and in particular, its key enabling element, which is transparent holographic display. And my immediate goal is to find partnership with an Air Force office so as to steer our F-Works phase 2 proposal towards specific platform and environment. And as part of this partnership, we will be seeking endorsement in the form of a customer memorandum. Next, please. In my definition, augmented reality comes in response to unsatiated desire to see more that meets our eyes. And augmented reality comes in two kind of big classes. It's HUD, head-up display, and near-to-eye display. HUD can be implemented on avionics platform. That could be fixed rotary wing aircraft, and it's specifically specific need for this HUD is on takeoff and landing, where the HUD would provide at minimum symbology on the landing, touchdown point, landing zone, etc. Similarly, it's on the left, you can see that's focus of my presentation. Similarly, HUD will perform kind of similar function on vehicle. Head-up near-to-eye display include head-worn component. It could be also helmet integrated display, where, for instance, for a bomb disposal suit, where you would put additional information, range to the explosive and other things that is required, increase situational awareness. It can also be integrated into a rifle scope, giving the sharpshooter target information as well as wind parameters, for instance. Since our school focus on avionics, we will be brief look at the market, which is, according to the study, is to reach 4 billion in 2022 for both civilian and commercial product. Next, please. Architecture, we call it Safe View, includes sensor suite, backbone, processor, content generator, and projector. As I said, our immediate call to fame is transparent holographic display, although our inspiration for the entire system. And the design of the system is to provide situational awareness without, so to say, taking eyes from the road, as well as reducing operator workload and stress. Next, please. Underlying technology HoloCore is a transparent hologram recorded on a flexible laminate. Oh, please go back. One slide back. Yes, thank you. Is transparent hologram recorded on a flexible laminatable film. Laminatable means it can put on glass surface. It also can be sandwiched between two glasses, and that's important for environmental stability. Glasses can be flat and curved due to flexibility of HoloCore, and that enables swap reduction and cost. Next, please. I should say HoloCore replace existing HUDs are based on optical HUDs. Please go back. Yeah, existing HUDs are optical HUDs, so they use optical components, and using hologram that combines in itself all these optical components allows the swap and the cost reduction. The key sort of beneficial features of this technology, it's we preserve the see-through property of the glass by reducing haze of the hologram and increasing transparency. We keep 90% transparency and above. We also maximize the information content by using RGB colors. So it's a full color hologram. Brightness is controlled due to high efficiency of the hologram, again, over 90% efficient. And important thing is we create out of plane image, which means that a pilot operator doesn't have to refocus eyes from the plane of the hologram to the far distance of the road or landing zone. The image is projected, so to say, virtual image over there. And that reduces fatigue and workload. Next, please.
30-second warning.
LGS is a mature startup, I would say. We have already 1 million in sales of holographic components, LSD, LSM, as you can see on the right. We are selling them to military aerospace primes. We have 1.6 million in SBIR won this year. We have demo program with OEM and major projector supplier. And we have a unique roll-to-roll process that permits high quality replication of these holograms. That's the key for commercialization. Next. Next, please. And what we are looking under the watchful eyes of our chief scientist, Dr. Dimov, that's our head-up display, head-worn display with the resolution chart that is shown on it. We are seeking for customer memorandum partnership with the Air Force organization to tailor our phase 2 proposal to actual environment. We also open, of course, to collaboration for other system integrations, for helmet, rifle scope, and we open to investment to accelerate time to market. Thank you.
Perfect. Thank you so much for presenting, Lev. Right now, we're going to open up the floor for questions for Lev. Feel free to kick it off. Dash, go ahead.
So the slide on the pilot view, my question is more related to when you don't have a pilot on board, how do we use, this is when it comes to autonomous unmanned vehicles, how do you think about the system helping in that case when there is no pilot to make that judgment? So this, so anything on that you have looked into?
Well, if there is no pilot either on board or somewhere else who would need to see, no, that's specifically designed for augmented reality. So you you would like to see something with your eyes and all the additional information to it. It's not
so
just
morely like, so if it's a remotely piloted aircraft and your line of sight, so when it's remotely piloted, the person is not really actually on board, but it's elsewhere. Does that have a limitation?
Well, one can imagine a situation for landing when you need to see the landing of the UAV and additional information. Yes, then it would be helpful to have augmented reality display. Yes.
Perfect. Thank you. We have time for one last question. Speak now or forever hold your peace. Otherwise, we will move on. All right. So we're going to move forward with Ravenswood Solutions. Tony Hawkins and Andrew Power will be presenting.
Hi, everyone. I am Andrew Power. I am the production manager at Ravenswood Solutions, and I've been with the team for about 12 years, since 2009 or so. Slide. Okay, as far as an overview, we are a for-profit, fully owned subsidiary of SRI International, founded in about 2015. Between SRI and Ravenswood continuing, we have about 25 years of experience in the simulation and training industry. And we find that we have a unique combination of engineering and military service in terms of how we develop and design our products. Slide. This is just a graphical overview kind of some of the customers we've had over time. The takeaway being that this is inclusive of both government and commercial, domestic and international, and research type projects all the way to products and production and services. Many of those logos are state guards, as well as the National Guard and some federal agencies and some civilian companies. Slide. So the gist boiled down of what we offered is improved decision-making. We take sensors, trackers, network, exercise control hardware, and we exploit them all together to improve situational awareness and therefore increase your ability to make accurate and timely decisions. We support the entire product life cycle, so from the R&D to production, as well as deployment of and further analysis and post-design services. So we are integrated, so to speak, in terms of the sensor and tracker end, the network or long path end, and the exercise control or decision support or after action review end. What I'll do now is dive into a couple current and one future specific products that are sort of why we're talking this afternoon. So slide, please. So first, this is our product called Orion. This is a homegrown 3D data visualization software suite. Orion takes in data like TISP type messages, video, annotations, tests or tactical engagement type events. And then it organizes, collates, and displays the data within a 3D environment. The user interface, which you can see here on the screen, it includes features like line of sight, for example, layered graphics, and a very intuitive data timeline, which you'll see in the multicolored lines at the bottom. And those show you all of the available data you have to basically click on and then arrive in time and space where that event happened in order to get playback and context of that event. So we're streaming this in real time with the additional availability of rewind, TiVo as we call it. Orion is also intelligent, so it's capable of things like conditional alerts that could be based on position or any type of constraints you set, as well as analytics, and those can both be done in real time or for after action review. Slide. Second product is Marty. Marty stands for Mobile Augmented Reality Tracking Equipment, and this is our self-contained mobile AR platform. It's designed to be used indoors or outdoors, and the specific niche we think we're in here is the minimal to zero need for infrastructure to operate. The takeaway from that being that potentially we can offer training to more people in a safer way, less expensive way, and still have accurate immersive training. Our unique IP related to Marty has to do with the very accurate location determination. So a combination of hardware and software and sensor integration. This is really important for this type of AR usage because as you scan the scene and look towards and away from and then back towards synthetic entities, the accuracy of your location helps to not make those things look jumpy or unrealistic or provide negative training. Our first target, and we have one sale so far with Marty, is the Forward Observer application. And at the same time, we're looking at other possible applications for that.
30-second warning.
Okay, slide. Last, we have GPS denied tracking. This is basically a spin out of the Marty. Again, there are many different industries within defense and commercial that have to do with precise location determination, whether you're indoors or just in a GPS degraded environment, trees, underground, things like that. Like Marty, the idea is operational without extra infrastructure indoors and outdoors. Slide. Okay, so basically these are the three areas that we're very actively invested in right now from a resource and expertise standpoint, and for certain reasons. With augmented reality, we want to bring safe, cost-effective, accurate, immersive training to more people. There are a multitude of applications for improved accuracy, and that's not just accuracy of location, but accuracy of all information. One example would be moving beyond laser for tests and improving realism in an after-action review or what you see on the screen. And then the analytics application is, better, faster decision-making, cost-saving efficiency, and predictive modeling. So I'll just reference the graph in the graphic in the bottom there. And the idea being that you can move up the maturity level of analytics to not just say what happened, but analyze what happened to maybe predict future behavior or even prescribe future behavior to your benefit. So the reason we're here today is to look for partners in the government and in industry to bring these areas into the market, to be teammates for competitive bids, to move these products and technologies forward, and to help us tailor our applications to more specific needs. So opening for questions, I'll also introduce my boss and the director of product development, who's Tony Hawkins. And go ahead.
Thank you, Andrew. The floor is open.
Sure, I do have a question. Have you been in touch with anybody at Air Force Research Lab that's also working on, alternative PNT solutions?
Tony may be able to answer more than I can. We're familiar with SBIR, and I've personally met one or two people, but not in a very targeted way, I'd say. Tony, can you elaborate on that?
Yeah, not to date, no. Army Research Lab is kind of where we've started. So yeah, no, that's, if they're in that space, that would definitely someplace interested to look into.
I can provide a name.
Okay, great, thank you.
Perfect. Thank you so much, Andrew and Tony. All right, we're going to keep things moving along with Sunray Scientific with Madhu Stemmerman. The floor is yours.
Great, thank you, Asher. Can everyone hear me?
Loud and clear.
Fantastic. Okay, good afternoon. I'm Madhu Stemmerman, CEO and owner of Sunray Scientific, We are a minority women-owned small business founded in 2013. We're located in Eatontown, New Jersey, and we're delivering revolutionary interconnect solutions for a connected world. Next slide, please. We currently work with some of the world's largest electronics companies. Sunray is a cutting-edge electronic materials company. Examples of our end applications include flexible wearables, medical diagnostic devices, smartphone displays, RFID smart labels, and a variety of semiconductor packaging opportunities. We are the novel electrical adhesive that makes a sensor, LED, or chip function. With explosive growth, the electronics world needs smaller, higher performing, and low-cost next-generation electrical interconnect solutions now. We offer superior performance and cost-effective solutions that overcome the limitations of traditional solder, wire bonding, and isotropic conductive adhesives, as well as films. Next slide, please. Conventional solutions require high temperature, high pressure, which are not suitable for many flexible applications. We use a magnetic field and low temperature. The simple beauty in our technology is a creation of vertically aligned wires, creating electrical connections using a magnetic field. Our proprietary materials and processes make this possible. The world needs a new technology to transform the way miniaturized circuits are created. Next slide, please. We offer advantages that are not available from any competing suppliers. We offer a smaller, stronger, lighter, more robust interconnect solution that works well in extreme environments, such as radiation hardness and cryogenic temperatures. And we've already addressed scalability and high volume manufacturing on standard equipment such as SMT. Next slide. I'm very fortunate to be supported by a top-notch team of technical and business experts. Our team comes from a diverse background, such as Bell Labs, NASA, Molex, and PPG. We continue to build out our staff and the capabilities towards high-volume military and commercial opportunities. Next slide. We have a portfolio of Fortune 500 companies spanning across healthcare, automotive, defense, and consumer electronics. We've had an ongoing commercial partnership with Hexel and Molex. We continue to be extremely successful in SBIR grants. We've won over 20 SBIR grants, phase ones and a few phase twos, equating to about $5 million. And we're very happy to announce that we've recently been awarded the TACFI Supplemental Pilot Program Award. Furthermore, we plan to pursue a StratFi award in 2022. Next slide. So our ask, we are very, very close now to getting into production. We spent a variety of years in developing our process, developing our formulations, and we're at various stages in regards to getting into production commercialization with a variety of customers. So we're looking for a $5 to $7 million raise here in order to accelerate our commercialization and advance further our high volume manufacturing capabilities and really penetrate the market, especially in semiconductor packaging. We're also looking for customers and users within, especially the Air Force and other arenas, in order to go after phase twos and phase threes and really gear ourselves up for the StratFi in next year. Next slide. I have a video that I'd like to show that demonstrates the robustness of our material. So basically we are the conductive glue that has attached these LEDs onto TPU. And you can see that we are able to light up those LEDs after a very rigorous stretch. This is very typical for our competitive materials. And I'm really happy to see this. And you guys can imagine that this would be used for basically placing electronics on garments, right? Or many different flexible wearable opportunities. So with that, I'd like to ask that I hope you'll join Sunray to help bring a world of family next generation materials for interconnect solutions into the world. And I'd like to open up the floor to any questions that you may have. Thank you.
Thank you. Thank you. Perfect. So the floor is open. Whoever wants to ask a question, please just ask. I'm going to ask again that everyone please keep your videos on. It's getting a little bit towards the end, but we want to have, you know, full activity. Thank you. Perfect. I'll ask the first question. In terms of the use cases that you guys have so far, in terms of basically the partnerships, where have, you know, is it mostly medical monitoring, or would it be more along the lines of I don't know, tactical gear? And where have you seen more of kind of a shift?
Yes, definitely in the e-textile, you know, diagnostic patches in order to get a variety of diagnostics. We've done a tremendous amount of work in that arena. We've also done work with focal plane array detector arrays, a variety of work on RFID smart labels. So our material can be used across many different areas, but especially flexible wearables. Because of our great adhesion, we're able to attach, whether it's rigid to flexible, rigid to rigid, or flexible to flexible. And our material can go across the board. So there are miniaturized electronics that require really fine pitch, especially in semiconductor packaging, and we're able to achieve very fine pitch as well.
Sure, thank you. Then also, Gilberto asked in the chat, what kind of scale can you achieve on flexible material without experiencing shorts?
Sorry, what was the question? What kind of scale?
What kind of scale can you achieve on flexible material without experiencing shorts? Maybe you can answer that. It's in the Q&A. You can go look at it.
I know we do have a variety of reliability data. We've demonstrated all sorts of attachment to a variety of substrates, PET, TPU, even paper. So I'm happy to provide any reliability data. Apologize, I'm not quite sure what scale means, but
Madhu, I can help with that if you want.
Okay, sure. Please go ahead, Andrew.
So if we're talking scale, I'm assuming he's talking pitch. So we've done down to 100 micron and below, around 90 micron pitch at high density. So you're talking about like a detector array that has, you know, that 720 pixel arrays. So we're comfortable right now doing wafer technologies down to around 100 micron pitch.
Great. Hopefully that answers the question. Thank you, Andrew.
Perfect. Perfect. Thank you so much, Madhu. And we are going to have the last but not least company, LidoCorp. Bill Davis will be presenting. Howdy, Bill.
Hey, how's it going?
The floor is yours when you're ready.
All right. So my name is Bill Davis, CEO of LidoCorp, and I'm here to talk to you about a big problem that's going on right now. Slide. The problem is our soldiers put their lives on the line with outdated tech. Imagine men and women hunkered down in a desert war zone, thousands of miles from home. They have it important to do, which is to keep us safe, but they feel isolated. They don't have access to this incredible tech since the acquisition process takes years for new tech to finally get into their hands. For now, they have to make the best of what they have available, even if that is something Frankenstein together. I've heard of stories of it works, but don't touch it, since they can't afford for their networks to go down. Unclassified, classified, and top secret networks each need separate secure devices in order to connect. Imagine needing to have 3 laptops, 3 modems, and 3 routers with you whenever you need to get to just to have connection to the data that you need to get your work done. Their packs are already heavy. Essential gear to communicate weighs even more. They deserve better. Next slide. They should have a lightweight, portable system that allows them to get their work done wherever they need to be. Whether it's from combat training to flight simulations, they should have the performance power at their fingertips instead of having to compromise or be weighed down. Next slide. After our first angel investors 50K, we won our first contract with the Air Force, and our product evolved to looking like this. With the phase 1 SBIR, it opened doors for us to talk with the military directly. PEO Digital at Hanscom Air Force Base liked our demo enough, they signed our phase 2 MOU. We want to lighten the load for JTACs and TACPs by replacing a few of their radios and the Humvee laptop with one tough kit. We tested this at Fort Campbell for 5th Special Forces Group Cyber Detachment. It worked for them, they loved it, and honestly, they didn't want to give it back after 2 months of testing. But unfortunately, they didn't have the budget to buy it. Next slide. Sergeant First Class Bear from 5th Group Special Forces told me that he would prefer Tough Kit over less expensive competitors' hardware because other hardware only does one thing. And he said nothing in this office only does one thing. So this is really technical. We could skip this for now. But our competitive advantage is that we could have one system that is not only your computer, but also your storage, network interface, and communications platform. So I mentioned some traction earlier. We had 50K in 2019 from our first angel investor and another investor in 2020. But in terms of the Air Force, we were selected for a 750K SBIR phase 2 through AFWorks. We have client deals coming through right now. We are growing. Next slide. Back in the day, you needed individual physical blades. Imagine different racks in a server for each type of service that you needed to accomplish. But now you can accomplish all this using hyperconverged infrastructure, or HCI. So we could take HCI even further and make it smaller and lighter without compromising performance. So what that means, millions or trillions of dollars worth of gear doesn't get left behind in a war zone. Allow every soldier to have access to the compute power they need directly. We're talking command, control, communicate, compute, hyperconverged infrastructure. Next slide. So in terms of the market, the DoD is large overall, but what we're looking at is becoming the Apple for the DoD. We want to make customized, powerful, sleek devices directly to the end users. And with the upcoming infrastructure bill with the Biden administration, we're looking at trillions of dollars of homegrown compute technology here in America, whether it's the silicon for computer processors or for graphics cards. More and more of this technology is going to be built right here in the United States. And we're looking to capitalize on being American made all the way. Next slide. So our ask, we're currently growing, but we're looking for $2 million of US trusted capital to accelerate our growth. So there's different certifications and qualifications that we need to have the authority to operate within the DoD, but we're looking to execute these high-level contract vehicles. We're looking to have the prioritization from chip manufacturers, whether they're Intel, AMD, and NVIDIA, so that we can get the supplies that we need to scale. And also, if we're going to have, we're also going to need enough people in order for us to scale as well. Next slide. So our team is Leo Villanueva and myself, Bill Davis, and we are LidoCorp.
Thank you, Bill. That was great. Perfect. So the floor is now open for questions. Don't be shy. Feel free to ask, and let's keep it moving.
I have a first question for William. I'm sorry if you can't hear me, I lost my voice. So once you're raising capital, it's always challenging to raise capital on a gov-focused business. I mean, if you have multiple markets, that's one thing. Or if you're dual use, that's one thing. But hunkering down just on gov, it's really sometimes very difficult to attract VC investments. What would you say to an investor at this stage about your commercial ambitions as well?
Yeah, so I appreciate the question. In the one pager read ahead, we did discuss a dual use market. We have interest in the commercial market as well, and we have other projects within LidoCorp that is also focused on helping people, whether it's trying to increase, be like an internet service provider in another country, or helping out with commercial markets in terms of some people have approached us for esports or gaming, but ultimately we want to be able to help people. And our other technology within LidoCorp is for suicide prevention tech.
Awesome. I throw out an idea here, just a quick follow-up about for mining. Sorry, all the hard words to say when you lose your voice. From the mining industry, I think would be an interesting space because they deal with a lot of connectivity challenged environments. And if your solution can help with that, I think that'd be an interesting poll.
Yeah, so in terms of mining, I think of different caves. I think about GPS denied environments, which was discussed in previous pitches. So we've explored some of that. Some of the things that have come up had to do with disaster response,
Sure.
or helping out with drones along that line as well.
Cool, thank you.
Perfect. We have time for one or two more questions. All righty. Last chance. Going once, going twice. All right. Thank you so much, Bill. That was fantastic. And I'd like to thank everyone who joined and presented, as well as our amazing panelists. Thank you, everyone who joined.